Yeah, so still you have significant biases as this region is mostly topographically driven precipitation. So what is your next step? Your PhD student, did you think about it?
Yes, because I will try to study the dynamic nature. Why this is happening? Why there is a bias, and if there is like increasing in the precipitation in the Himachal. So what's the cause of this? So I will go behind the causal factor of this.
Yeah, but still improvement factor. Improvement. What is the way how to improve the biases? I know that you can see the physical basis of this excess precipitation or dry bias, but at the end you have to improve it, right?
Yes.
The best way is you either use AIML or at least convective fermenting scale simulations where you can resolve the convection explicitly. One thing. Second, we both are from Icrc. There is no such department, Earth and Environmental. The Earth and Environmental Sciences. Add it. Right?
Yeah, sure. Thank you so much,
Yeah.
sir, for the.
Hello, Jyoti. For my own understanding, could you please define what is the extreme precipitation E-band in terms of the amount of rainfall and time? What we call extreme?
We have to have some kind of threshold.
What are these thresholds?
Okay.
You are all the time talking. What is that for the policy maker? What is that?
So
How to define?
it is different for the different.
Yeah, for Himachal Pradesh.
I'm not still updated with this. What's yes. Yeah, but I
We will discuss later because I need this information.
Yeah, sure.
Please.
Sure.
Thank you so much.
Okay, thank you very much. Right after your next speaker, Jake.
How to make like this.
Good morning, everyone. I am Dr. Javed Akhtar from Department of Atmospheric Science, University of Calcutta. Today, I am going to talk about machine learning-based lightning prediction over system. So we know lighting is one of the deadly atmospheric phenomena that cause serious threats to human life and property. And in India, nearly 2,000 people died due to lightning, which is about 9% of total deaths due to the natural disaster. But one problem of lightning study is that there is limited availability of lightning data, especially over India. So one way may be to develop the lightning data, proxy lightning data, using other atmospheric dynamic or thermodynamic variables, using the machine learning approaches. One problem of developing machine learning models with the needed data is there are presence of spatial autocorrelation, SAC. So that may cause some problems. To avoid that problem, we have to use some spatial predictors. Here we have used the modern eigenvector maps, MEMs, as the spatial predictors for removing that autocorrelation and develop the robust ML models. Data we have used TRMM data, which is available from 1996. So data period is limited, not much data is there. And we have taken other atmospheric variables like CAPE or convective precipitation, TCWB, TI index, specific humidity, convective humidity at various spatial levels from the ARV analysis. Now, this is the spatial autocorrelation. In first figure, we can see positive spatial autocorrelation. Here we can see the adjacent points are very similar. In case of negative spatial autocorrelation, the adjacent points are or adjacent bits are completely opposite. So, and they are zero spatial correlation and random spatial correlation. There is no such pattern. So this is the third one, which is most desired one. But we have to first check whether this autocorrelation are present or not. So what the autocorrelation causes problems? First, it violates the assumption of IID errors and infers the type on pairs which used in the standard statistical procedures. It can even invert the slope of relationships. And also the precision of standardized coefficient produced by the regression, it can be significantly when there is autocorrelation present in the residual. And we can estimate the spatial autocorrelation using Mohan size statistic equation is given here. And the null hypothesis is that we assume the variable is randomly distributed. Now, if the p-value is significant, then in null hypothesis is rejected. That means significant autocorrelation is present. And if it is insignificant p-value, then no, that is then random autocorrelation. And how to remove this spatial autocorrelation? One approach is Mohan's eigenvector map, MEM. It is basically can be extracted from a W-center spatial weight matrix as given below. I am not going to the details. Okay. Now the total methods of my study. First, we compute the atmospheric predictors from reanalysis, then screen the predictors using correlation plot and score. We take the predictor highly correlated with the lightning data and also use VIF score, variation infection score, to check whether temporal autocorrelation is there among them. After screening using those two, we use the machine learning models. We have here used 4 models: SVM, GBM, neural net, and random forest models with the selected predictors. And then I compute the Mohan's I statistics from the residuals of the machine learning models. So if the residuals, the Mohan's I from the residuals is significant, in that case, we have to create the MEMs to avoid the spatial autocorrelation. So we create the MEMs and combine them one by one with the exacting predictors. Again, we screen using the VIF score and correlation. And then again, we run the MEM models with this combined predictors until the Mohan's I becomes non-significant. Once we have found that Mohan's I becomes non-significant, here I have plotted the lightning primatology from TRMM data. And the first one is pre-monsoon, then monsoon, monsoon, and so you can see the significant lightning occurs only during the pre-monsoon and monsoon. We have taken these 2 seasons for our analysis. So here is the result of a support vector machine. This is the result for training period, which we have taken from 1996 to 2010. So here we can see the first one is a non-spatial model and second one is spatial model. In non-spatial model, the Mohan's I is 0.222 and p-value is given. That means significant autocorrelation is present. But in spite of autocorrelation, it has performed quite well. You can see the R-square value is 0.88. RMSE and MAE, the error indices are quite less. After incorporating of 3 MEMs, we can see the autocorrelation has been removed. That p-value is non-significant now, 0.26. And Mohan's I is very less, 0.002. And it has removed the autocorrelation, but also improved the performance. R-square has improved now, 0.97. Also, RMSE and MAE has. And here is which predictors are important. We have shown in this plot. So you can see from atmospheric predictors, KF and TCWB are important predictor. Things. Now we have made the testing with the remaining 3 years, 2011 to 2013, and we can see the spatial pattern of observed, and this is the spatial pattern of the spatial SVM. So you can see the matching is quite good, but very good from confirmed from the correlation is 0.97, D index 0.98, NSE 0.91, and RSI, which is the normalized RMSE, is 0.29. It's quite well. So spatial models have performed quite well. And similar things have done with the GBM gradient in between. Neural net. Now we have done the same thing with monsoon also, and we have shown a comparative performance in this model here. So from R-square you can see left side is non-spatial and Here, so spatial R square has improved in both and RMSE and MEI decreased in both seasons. And one thing, if we compare two seasons, the R square value is more in case of pre-monsoon than monsoon, but RMSE MEI is less in monsoon. Now we have compared the validation period or testing period of our two seasons. We have checked here. So here we can last slide. So here we can see the correlation is quite close in both season. D index and NAP is greater in case of the MEM and RSI also less. So here from here we can conclude that the model perform better in case of and one thing is in case of non-spatial models, SBM has performed better, and in case of spatial model, we can see the neural net has performed better. That's it. Thank you.
So can I have a word or two for comments?
Javed, you presented well. So I have a very basic question. That all the spatial maps are focused into Eastern India. Is there any scientific reason for that?
Actually, my study area was Eastern India in my project. So
Thank you so much.
it can be done over throughout the India or any other.
Okay, thank you so much.
Just a small question related to this one. Okay. So you see, our northeastern Meghalaya foothill, we already covered most of the part of Bangladesh. So you miss the main hotspot area that is called Sunamganj. So we use just increase, I think, 1 degree, it will automatically cover. That is the one. Another is a very good interesting study. Of course, it is a new method now people are using. The data time limitation, right? So what would be the next approach? Because it is ended at 2013.
Now we can use this approach and we can use the predictors of rest of the time like 2040 to 2022
From where?
from era 5.
Okay,
Era 5, I have taken from era 5.
thank you.
Yeah, thank you very much. I'd like to move on to the next computer. Okay, it's Manjeshu Goswami. Yeah.
Good morning, all of you. Myself, Manjesh Goswami. I'm presenting my PhD work. Before proceeding, I will thanks organizer for giving this opportunity. In this study, we are discussing on soil water dynamics in extremely dry and wet rainfall conditions over the core monsoon zone of India. With the motivation objectives. In this, understand the surface and subsurface processes and their linkages to the land atmosphere energy exchanges. Soil moisture affects regional hydrometeorological actions. Yes, you can use here. And objectives are analysis of soil water dynamics using soil moisture observation and thereby surface and subsurface coupling and memory. Another objective is understanding of soil water dynamics during regional extremes on the successive winter and pre-monsoon conditions. Soil water dynamics has various important factors such as precipitation, infiltration, percolation, evapotranspirations, and soil moisture. Soil moisture is a key variable controlling numerous processes and feedback loops within a climate systems. Also, it plays an important role in Earth hydrological cycle and energy balances. By controlling water and energy between land and atmosphere through evaporation and transpiration. Also, soil moisture not only regulates the partitioning of nitrogen into sensible heat, latent heat, and ground heat products, it also helps in partitioning of precipitation into evaporation, infiltration, change in soil moisture, and runoff. To study these surface and subsurface processes, we have carried out analysis over the core monsoon zone of We have carried out to study these surface and subsurface processes. We have carried out analysis over the core monsoon zone of India using MD observations. Here in figure C and U, we are showing the surface and subsurface soil moisture variability with respect to concurrent rainfall and temperature anomalies. So we can clearly see during deficient years, the soil moisture variability is weaker as compared to the excellent years. These higher soil moisture variability in subsurface conditions, subsurface observed in a satellite realization model that approaches. Therefore, it highlights the importance of subsurface observations to study these surface and subsurface processes and soil water dynamics. So one question arises: how does soil moisture variation regulate soil water dynamics and have an impact on successive seasonal conditions? To study these, we have carried out analysis using surface and subsurface coupling and soil moisture memory. So here we are showing the two contradictory years, deficient excellent years, and we are studying the soil moisture variability and soil surface subsurface coupling. So here we have compared coupling using cross correlation analysis. So in deficient years, coupling is weaker as compared to the excess years, and in deficient years, surface leads subsurface, whereas in excess years, subsurface leads surface. So it connects to the soil moisture memory in such a way that during deficient year, soil moisture memory is decreased by 50%, whereas in excess years is increased by 7 to 10%. The higher subsurface memory is more pronounced in excess years. It has the higher subsurface memory might have implication on successive seasonal conditions. So let us see here. During deficient year, the negative rainfall anomalies are higher. So there is less moisture available for land atmosphere interactions. So it suppresses the convective thunderstorm activity during successive pre-monsoon conditions, resulting higher bottom ratio. And on the other hand, during wet condition, there is sufficient moisture available for land atmosphere interactions. So it is conducive for the development of convective and thunderstorm activity during successive seasons, which suppress the bottom ratio during these conditions. This is also seen using the temperature extremes over the Indian cosmosite. Here we are showing the observations for the period 19 to 2022. 19 is a wet year, so we can clearly see the sufficient moisture available at the end of December. So it is conducive for development of convective activity, resulting in successive pre-monsoon conditions. We'll see the higher moisture and lower temperature, concurrent lower temperature at both surface and subsurface conditions. On the other hand, 2021, this is very less rainfall at Cosmos site, so resulting very less moisture for land atmosphere interactions. And we can see the resulting in 2024 pre-monsoon conditions during so very low soil moisture and higher temperature extremes at both surface and subsurface levels. So these observations are crucial to get insight into the regional climate change. Thank you.
Thank you very much. Can I ask a couple of questions, comments to the presentations?
Yeah, here I have one question. Nice presentation, Ganesh. Good that you have nicely, investigated soil temperature and soil moisture and precipitation dynamics. It might be a first question, but I just wanted to know how much soil do you need to get to convert into precipitation? Right? It's very clear that less soil moisture, less precipitation. More soil moisture, more precipitation, right? quantitatively can be just, you know,
Mostly it's depends on regional conditions. So it requires larger area.
yeah, so monsoon cohesion is well enough.
Is yes.
Yeah, it's, I think simple, maybe you can do the small scatter plot where you can, you know, soil moisture in x-axis, y-axis for your precipitation, and then you see how valid is the result. Thanks, Ganesh.
Field capacity can find.
Yeah, probably not only for some nature, but also for a ratio or any flux, those types of temperature could be preferable to analyze at the same. Okay, any other? Okay.
Yeah, thank you so much. Which are the major physical condition and the land use pattern which is affecting the spatial pattern of soil moisture? Did you consider those?
No, most of there are various factors that affect the soil moistures.
Yeah.
There are some land hydrological parameters like soil textures and some atmospheric parameters also, radiation, temperature, and pressures also.
You consider all those?
Yes.
Did you also consider the land use pattern?
No, in that we have considered only.
Okay. Thank you.
Okay. Thank you very much. Let's move on to the next presenter. Should Sati Kumar, he's online.
Not online. Not online? Yeah, Sutin Kumar is not online.
Not available. Oh, yeah. So we should move forward. It's Pawan Kumar. Okay.
Okay. Very good morning to all of you. I am Pawan Kumar Chaudhary, PhD scholar at Banaras Hindu University. Title of the today presentation is frequency of extreme precipitation is projected to increase during 21st century over the Indian river basins. So to introduce the topic, it is very important to understand hydroclimate extremes like drought and flood strongly influence. Hydroclimate extremes, drought and flood strongly influence global as well as regional water resources. Also, it have a severe impact on the different socioeconomic sectors such as agriculture, health, and water resources. In the recent decade, 20 to 80 millions of the global population affected due to flood every year. And IPCC recently reported that due to the global warming, hydroclimate extremes increase globally and its affect the natural and man-made ecosystem. According to Indian government report, after 1950, India experienced a huge number of flood events and that affected the billions of the populations, damaged the agriculture area, and killing more than 1 lakh people. National Water Policy 2018 emphasized the integrated assessment of the water resource management at the river basin level. So it's very important to understand how hydroclimate extremes changes over the different Indian river basins. And this is my study area here. You can see that major river basins of India and the highlighted line shows the climatic zones of India. So now to analyze the extremes over the Indian river basin, I use the IMD needed rainfall data sets and future projections. I use CMF6 simulated output and intensity of the extreme rainfall I characterized by the India Meteorology Department, that is the 244 mm per day considered as the rainfall extremes, a generalized criteria by the Indian Meteorology Department. So I to examine the extremes, I use different methods, generalized extreme value distribution to examine the return period of the extremes, and I applied bias corrections with 6. climate model data. I use standardized precipitation index to examine the wetness and dryness conditions over the different Indian river basins. I use ETCCDI indices, different ETCCDI indices to examine the future projections of the streams, and using Mankandar trend test to examine the trend of the streams. Here it is the different Indian river basins, and red dot shows that the major hotspots which examine the streams at the 99th percentile. And when we examine the probability of the monthly scale rainfall, then Brahmaputra and Ganga river basin shows that the maximum amount of the rainfall per month. And when we analyze the heavy rainfall over the last 119 years, then we found the central India and the extreme rainfall mainly concentrated over the western part of the Indian river basins. And when we examine the extreme rainfall event at 40-year time interval, then we found the after 1981 rainfall extreme mainly concentrated over the west part of the Indian river basins. Also, the highest 5-day rainfall amount is increased after 1981. And when we examine the return period of the rainfall streams at 10, 30, and 100-year return period, then we Central India and Peninsular Indian river basins shows the more variability in the rainfall streams, and Indus River basin shows the about 300 mm per day at 30-year return period. When we examine the decadal trend of the spatial variability of the rainfall, then we found after 1981 rainfall significantly increased western side of the Indian river basins. And also the similar pattern observed in the monsoonal rainfall, and the western side of the Indian river basins shows the increasing trend of the monsoon rainfall. So it is the major hotspot for the streams, and during the 1981 to 2019, there is the drastic changes in the rainfall observed over the western side of the Indian river basins, and that indicated the new region and make that the western shifting of the rainfall streams in the last 119 years. So before proceeding the future streams, we applied the bias correction, different bias collection method, or the simulated output data, and we found the root mean square error varies from 3 to 3.5. That indicate the moderate level of error. However, the standard deviation varies from 2 to 3.5, and that indicate the more variability in the prediction of the models. So we applied the multi-model mean approach, and we found the good correlation in the observed data set, that is the 0.85, and this is the spatial variability of the. And now the observed rainfall data, you can see in this figure the spatial pattern of the observed rainfall and multi-model mean approach. Before the bias correction, you can see the high uncertainty in the multi-model mean, but after the bias correction, it reduces and it varies from minus 0.3 to 0.9. So after bias correction, we examine the percentage change in the future precipitation, annual mean precipitation, and I found that the lower Ganga basins shows that the decreasing rate of the mean precipitation in near future. However, the Indus and Upper Ganga basin shows the increasing rate of the precipitation 10 to 30 mm per day. And when we examine the intensity of the streams event, then we found the 14% about the intensity will increase in future over the Upper Ganga and Indus River basin. However, similar result has found in the frequency of the streams in the Indus and Upper Ganga basin. While the dry days will be increased over the central and downward of the Ganga river basins. And when we examine the probability of the precipitation streams in future, then we found the Indus and Upper Ganga basins shows the high probability that varies from 500 to 1000 mm per day in the 10-year return period. So now I'm conclude my research, and I In the last 119 years, the stream event has been increased over the different Indian river basins from 15 to 16% about, and most of the part of the western side of the Indian river basin. So it's we can say that there is the western shifting of the rainfall streams in the last 119 years. Simul 6 shows the more intensification of the streams over the western side of the Indian river basins, and downward side of the Ganga river basin show the future drought conditions in future. Finding of this research has been published in these two journals, Earth Future and Earth and Space Sciences. Thank you.
Okay, thank you very much. Can I have a set of questions? Okay, first of all,
How many models you have considered in each SSP wave models? Any vision for selecting specific wave models?
I choose the best 12 model for the Indian region. I downloaded.
Initially, you have taken how many? Initially, you have selected.
Initially, we downloaded 18 to 19 model, but after filtration, we selected only 12 model, and we take multi-model approach.
Yeah, thank you, Pawan. Very interesting presentation, quite relevant, not only not downward, downstream.
Sorry, sir.
Yeah, downstream and upstream.
Right.
So it is
Down part.
very relevant to generate flood modeling, upstream and downstream. But do you think that without considering the upstream areas of the river basin, this study is incomplete?
Actually, sir.
No relevance. So would you suggest, as you already mentioned in your introduction, the new water policy of the government of India, 2018 suggests that the water resource management should be at the river basin level. Just suggestion, okay? So do you think that we need to collaborate with Nepal, Bhutan, even with Pakistan, to have an integrated river basin management for forecasting, modeling the flash flood and floods? This is interesting. This seems relevant.
Yeah,
Okay, thank you.
Sorry,
Sorry, sir, for the interruption. Bangladesh also. I forgot.
Even China also.
Yeah.
All the neighbors, yeah.
The small query regarding the bias correction. So I think there are lots of bias corrected data already been there. So why you have take another one initiative to bias corrected data? Have you compared whatever already been there?
Yes, we applied the 3 bias correction: linear scaling, local intensity scaling.
But some bias data is already there.
Already there, but we have used our method, and I hope my method is better.
But it should be different.
I have a quick question. You, in your presentation, thank you for your presentation, because this is very important for the region. You keep mentioning in your presentation Upper Ganga Basin and Lower Ganga Basin. You did have some basin level analysis too.
Yeah, special pattern to intensify streams, but the lower Ganga Basin shows the deficiency of the stream. So I characterize like that, spatially. Visually.
Necessarily.
No, I'm next working on the Ganga River basins in the warming 1.5 global warming scenario, and will be researchful.
Can I have
Yes.
more questions?
Yes.
Could you have a comments on the reasons for the change in the region and also, reason and process? Atmospheric and atmospheric hydrological processes of the change. The process changing the reason. And also, they have a comment on the consistency between the models with projection. What's the agreement of the what's the ratio of the agreement around the models, of course? They have a comment on the two points.
Consistency of the model agreements. I use 12 models, and during the bias corrections, we observed the. Actually, I am not understanding your question, so what do you?
Yeah. So first question is the reasons, mechanism.
Okay.
And the second question is the agreement between the 12 or 16 models.
Agreement we are analyzed due to the for confidence level, we significant and applied the 95th confidence interval level. So the most of the portions trained analysis on the based on the 95th confidence interval. So is a good agreement of the model in the spatial pattern and mechanism behind the
Mechanisms behind the change.
stream. Depending on the Arabian Sea increasing moisture flux and it's completely merged over the western side of the Indian River basin. That streams will be changes over the western side of the Indian.
So those kind of the cause of the change in the processes are in the agreement with among the models. Yeah, overall, those kind of the process could be play an important role to increase the experiment over the region. That those kind of important process is in the agreement with the models.
No, sir.
I have one thing to add on to it. Can I just have one thing?
Okay, go ahead.
So in addition to what Professor Koji is asking, in terms of the selection of the models, you went from 20 to maybe 12
models.
12 models. So what were the criteria?
I used the correlation structure and I found the best model. I have highly correlated with the observed rainfall data
But is
set.
that enough correlation? The reason I ask is you're looking at extremes. So when you're looking at extremes, maybe you need other parameters to really compare and to select the model.
Previously, I written most of the paper and they also use that models for the Indian region and the model is giving the output for the Indian region. Maybe parameterized in that models is better for our region. So I use that models.
Yeah, one of the ways that we had done, my colleagues, was that they looked at the shape of the hydrograph. Okay, so if the shape of the hydrograph in all those models are adequately representing the exact shape. One, two is that whether the volume in the monsoon period, because the most extremes happen. Volume in the extreme of the monsoon period, whether that matches, or the best that matches that. You know, so those two criteria were used to.
I will consider it my
Yeah, you may
paper.
want to do that.
Yes. Thank you.
Yeah, we are running slightly late, so maybe we can quickly go to lightning talks if please.
Yes, also, right, because one presentator was skipped available. So, yeah, fortunately, we have a time. Okay, anyway, but we'd like to move on to the lightning talk. So Chika, you check the availability of lightning. Yeah. Lightning.
Okay. Thank you. So today we will go on the lightning talks. So I request everyone to be on time and I will play a bell at exactly at 2 minutes. So after listening the bell, you just conclude it and don't show any other things. Just conclude. Okay, because we don't have time. So first I will request Kathy Richardson. The presentation will be on quantifying current and extreme precipitation events in Nepal to inform our stakeholders. So online.
No, she is not online.
I saw her.
Yeah, earlier she was online.
Okay, then we'll go to second one. The next one. The next one by Paul Artigar is here. Yes. So the presentation will be about greenhouse forcing and its amplification mechanism on Africa's outrage and night.
So Paul, could you share the screen? Oh, can you hear? Okay.
Can you see my screen?
Yeah, we just agree. It's all.
Okay, thank you. So I will briefly introduce my poster that focuses on greenhouse forcing and its application mechanism on hot day and night in Africa. Majorly, in recent years, Africa has witnessed.
Could you speak up?
Can you hear me now? Can you hear me?
Hello,
Can you hear me?
can you use the microphone?
Can you hear me?
Yeah, you can carry on.
Okay, thank you. I will introduce my poster on greenhouse forcing and its application mechanism on Africa hot day and night. So in recent decades, Africa has witnessed a notable increase in surface air temperature. So one of the reasons is that due to the long persistent impact of some of these greenhouse gas, such as carbon dioxide, so understanding is not enough. So due to this reason, we have developed a large single forcing experiment so as to understand the impact of this external forcing and then how they are amplifying extreme temperature over Africa. So we are using the regularized optimal fingerprinting. So that is what we are actually expanding. We are expanding the optimal fingerprinting equation to actually understand the influence of anthropogenic forcing and natural forcing, and also we are understanding the influence of greenhouse forcing, aerosol, and also natural forcing combined on this extreme event. So in figure 1, we can see the influence of external forcing on extreme precipitation. This shows that majorly the amplification of this extreme event is actually due to greenhouse forcing, whereby aerosol forcing, on the other hand, shows a decreasing trend that shows a corroborating effect on the amplified warming. So the three signal detection shows that majorly across every region which we consider in Africa, we could actually detect the signal of greenhouse gas, whereby majorly we can see the best estimate scaling factor of for during the day shows about 1.79 confidence interval. And then so in order to because the major forcing controlling this effect is greenhouse forcing, so we examine the sensitivity of CO2 forcing to these hot days and nights. So we bin the into 5 increment the sensitivity of CO2 to amplify warming. We have been
2 minutes.
okay, thank you. So they are being into 5 increments. So one of the things we see that under each bin, CO2 scenario indicates a high sensitivity to the abrupt doubling. And then we can see a wider divergence between the relationship during the logarithm effect. So our results conclude that the significant equilibrium temperature is dependent on CO2 sensitivity, and also there is an increased warmer under CO2 doubling. So thank you so much for listening. I will be glad to answer any question.
Thank you, Paul. So we'll move to the next presentation. It will by.
Yeah, just a minute. Katie has sent her presentation. Oh, she's not online, but she sent her presentation. She's having some technical issues.
Okay. Can you play or what?
I wondered if it has come in our.
Okay.
In the meantime.
Yeah. Okay. Thank you. So we'll move to the next presentation by Nasim Hussain Hamza here. Nasim.
She's not online.
Okay.
She sent it.
No, Nasim. Okay. Okay. Next one is by Ajikya Ajwale here. Okay. He will be presenting about impact of North Tropical Atlantic on South Asian summer monsoon variability. Please. which there is another one. You skip it.
Hello, good morning, everyone. I am Ajinkya Solek, a research scholar working with Dr. Suraj Kepi and Dr. Swapna Panikal at CCCR IITM Pune. First of all, I would like to thank the organizers of the conference for giving me an opportunity to present my poster entitled as Impact of North Tropical Atlantic on South Asian Summer Monsoon Variability. I will emphasize the findings of my research first. The evidences from the observation and by control data sets of IITM ASM coupled models shows that there is a pronounced biennial nature of NTA ENSO ISM system, as the NTA is an plays a precursory role in the ENSO ISM system. The result is the coherent association between the South Asian summer monsoon with strengthening during the positive phase of NTA and weakening during the negative phase of NTA. Now I will talk about the mechanism that justifies the discussed findings. The warm and cold NTA SST anomalies over the NTA region alter the ENSO condition over the Pacific Ocean, and through the ENSO, NTA drives and dynamic response over the South Asian summer monsoon region that will enhance the rainfall activity with the enhanced monsoonal flow. Further, this hypothesis is supported by the IITM ASM coupled model, which is now part of the CMIP 6. Its hypothesis the key role of NTSST in the reversal of ENSO condition over the tropical Pacific. Further, it illustrates the nonlinear characteristics of the NTA ENSO ISM system, as cold NTA perturbations are more influential than the warm NTA perturbations. Further, the discussed result is documented and published in the Climate Dynamics. Thank you.
Okay, thank you very much, Ajinkya. We will move to the next presentation by Deepak P. is here. Okay. He will be presenting about exploring the vertical mass thermodynamic characteristics of extreme rainfall events over monsoon pool region.
Good morning, everyone. My name is Deepak B. I'm a junior research fellow from Icrc Mohali, working with Dr. Raju Attada. So my study for today is that exploring vertical mass thermodynamics, exploring vertical mass thermodynamic characteristics over the central Indian monsoon extremes. Central Indian region, it's like majorly rain-fed agriculture region. So it is particularly vulnerable for extreme rainfall events during the Indian summer monsoon season. So we would like to, in this study, we would like to explore the thermodynamics characteristics and the underlying physical processes of these extreme events. So for this study, we have utilized IND rainfall data and RFI synoptic and insat data for some validation purposes. So so in this study, we have found that almost 60% of the extreme rainfall events during some Indian summer monsoon region or the central Indian region is due to a large scale precipitation, and 40% or less than 40% of the precipitation is due to convective precipitation. And we can see this over here, and total precipitation, and this box is for central India, which I'm talking about. And moving on to the moisture transport, which we can see from 6 days prior to the extremes, we see anomalous moisture reduction from Arabian Sea as well as Bay of Bengal. This moisture converges into central Indian region due to strong cyclonic circulation over the Bay of Bengal. This is the reason we would is that moisture is being transported from Arabian Sea into the peninsular Indian region, and then Sorry for the interruption. So this is the reason for moisture advection, and then we would like to go into the effects. So while investigating the vertical profiles, we saw anomalous warming and cooling in the tropospheric region, and then we saw.
Can you conclude?
I'll let you conclude, and then this anomalous moisture transport, and this anomalous warming and cooling is in the inside profile surface. We also saw the moisture budget, and we found that vertical advection precedes the Indian monsoon extremes. And, this is a short summary of my study, and thanks so much.
Thank you, Deepak. We move on to the next presentation by Abhiram Nirmal CS here. So he will be talking about future changes in the potential intensity of tropical cyclone over North Indian Ocean in response to the thermal structure of the atmosphere and the ocean in CMIP models, CMIP 6 models.
Hi there. We assess the tropical cyclone activity in the projected tropical cyclone activity in the Arabian Sea from using the high resolution project of CMIP 6 models. Now we have used the CMIP 6 high res MIP of the CMIP 6 model, which actually has a higher resolution than the usual CMIP 6 models. The usual CMIP 6 models have a typical resolution of hundreds of kilometers, wherein the high-res MIP has a resolution of better resolution of around 50 kilometers or better. So we have used this high-res MIP and 8 models from the high-res MIP experiment, of which the table 1 shows the models we have selected. For the historical period, I have selected the 1915 experiment, which are coupled models. And for the future projections, high-res future is selected. Both are coupled models, type 2 experiments. This is for the ocean component also. So because our analysis needs the ocean components too. And our analysis, the results are given, the correlation coefficients are given in the table 2, which shows the area average values for the area average correlation coefficient for the variables we have used. And this one shows the our analysis region, which is the Arabian Sea only. And we calculated the GPA for the Arabian Sea area, which is the manual and nodal GPA, and we are getting a very good ensemble mean here. This figure 1 shows the ensemble GPA, and for the post monsoon season, the GPA is very well matching the observation from the ERA 5 October, November, December season. And for the historical period, not the historical period, no, for the MMJ season, the historical period is matching, but there is no change in the high-res feature, as you can see here. But for the post-monsoon season, there is an increase in the GPA values over the coast in western coast and close to the equatorial
So
region.
Hiram, please conclude. Please conclude.
And these figures 3 to 5 show the area averaged and vertical averaged variables, different variables. Figure 3 show the
Please
equivalent.
conclude. We will visit your poster. You can explain there. Please conclude.
So we are getting an increasing in the sea surface temperature, subsurface temperature, ocean subsurface temperature, and the equivalent potential temperature.
Thank you. Thank you, Hiram. Next is Ruta Sain. Is there? Yes. You will be presenting about evaluation of monsoon precipitation extremes in world-based dynamically downscale reanalysis over the Indian Himalayas. You don't have any pen drive? Oh, okay. It's better. Yeah, please tell me.
Good morning, everyone. I am Rohtas, PhD scholar from Icrc, working in the climb group with Dr. Rajma Dada. So today I will be presenting my research work on extreme event over the using work model. So we know that Himalayas are highly vulnerable to the extreme rainfall event, and however it has some complexity, heterogeneity, and a lack of meteorological data. So we do investigate this spatial temperature, temporal pattern, and extreme rainfall event. We need high resolution data. For this study, we use dynamically downscaled work or WRF data to investigate the extreme precipitation event. So our result underscores that so if the high resolution data set so that spatial temporal precipitation variability over the Himalayan region, and if we see the spider plot, we can conclude here that it well represent the extreme precipitation event with respect to era 5, and if we see the extreme event at 99th percentile, we observe major precipitation occur over Himalayan foothills region, and WRF model data represents daily extreme indices in terms of intensity, frequency, and duration. And if we see the evaluation of vertical moisture thermodynamic structure, we can see the high vertical integrity moisture transport available over the high mountains, how high South Mountain Asia region. And if we see the time evaluation, we can observe high moisture inclusion and the moisture during the extreme event. And if we conclude my research work, we can see that high moisture coupled with the strong cyclonic lower level cyclonic circulation and high mid tropospheric instability give the signal of extreme events over the Himalayan region. In addition, dynamic component of the moisture budget influence more during extreme. Thank you. Thanks.
Thank you, Saini. Next is Atira. She will be presenting about unveiling the distinguished features of normal and extreme cold wave events in the country.
Good morning, everyone. I'm Adira, a PhD scholar from Weather and Climate Modeling Lab, Department of Earth and Environmental Sciences, ISA Mohali. My poster deals with the study of the circulation patterns of distinct cold wave conditions in North India. Cold waves are extreme weather events which is characterized by abnormal low temperature which continues for a few days. And the present study explores the distribution features of the normal and intense cold waves over the northern parts of the country during the boreal winter season from 1980 to 2020. So a region is selected where the climatology of the minimum temperature is less than 12 degrees Celsius and where there is maximum variation of the minimum temperature for the identification of the cold wave events. The normal cold wave events are identified when the normalized minimum temperature anomaly is between less than -1 or greater than or equal to -2 standard deviation for 4 or more consecutive days. And for intense cold wave events, this is less than -2 standard deviation for 4 or more consecutive days. Further, we carried out a composite analysis to study the large-scale circulation patterns associated with the normal and intense cold wave events. And it was found that the spatial extent of the intense cold wave event is almost double than that of the normal cold wave events. And the normal cold wave events are favored by the westerly movement of the upper level trough and the associated circulation. And the cold wave conditions occur on the rear end of the trough. This suggests that the cold wave conditions occur after the passage of the western disturbances. In the case of intense cold wave events, the intense cold wave event is favored by the strong southward cold air attraction from both the Ural-Siberian region and the Arctic region. So there is an omega kind of blocking which happens over the Siberian region, and this blocking condition blocks the eastward propagation of the winter weather systems, and the downstream end of the block carries the cold air from the high into the lower latitudes, thus bringing the intense cold conditions over the northern parts of the country. That's all about the poster. Thank you.
Thank you, Raja. Next presentation will be by Raj Pritam Gupta. Okay. He will be presenting about sensitivity analysis of physical parameters and schemes for Western disturbances over the Indian region and high resolution work model study.
Good morning, everyone. Myself, Raj Pritam Gupta, and I'm going to present my poster on the topic sensitivity analysis of physics parameterization schemes for Western disturbances over the Indian region, a high resolution WRF model study. So, in the northwestern region of India, experiences heavy precipitation primarily during the winter season due to the low pressure synoptic weather system known as Western disturbance. These WTs cause heavy precipitation, cold winds and fogs in northern India, which disrupt daily life. The study aims to set up a numerical weather prediction model WRF over the Himalayan region and study the dynamics of WT. Sensitivity experiments were performed using the available physics options. 3 WTs cases were taken, and for the WTs initial and boundary condition, we have taken NCEP FNL data. And to compare the precipitation data, I have used the GPM minus data. This is the study region which I have taken, and with two domains. The figure here shows the physics parameterization schemes, and only the microphysics options is used for the sensitivity experiment. The results of precipitation equal to that, the MP physics option gives the best results when compared to GPM. Then this is the vertical profile of the wind over the whole domain. This is the wind profile at 400 HP of my study region, and behind this is the vorticity. So the conclusion is that the performance of combinations of Thomson's microphysics scheme, increased cumulus scheme, Yonsei scheme, Julia scheme, and rapid radiative transfer scheme that shows the best result for precipitation. The physics option that gives the best output cannot necessarily suitable for others also. The model was good enough to capture the large scale system like subtropical westerly jet stream. Thank you.
Thank you, Raj. We'll move to the next presentation. Madhusudan Ingale. Yeah. Okay. He will be presenting about evaluating complexity of the soil and correlation over 4 months of India.
I'm Dr. Madhusudan Ingle. Let me thank organizer for the opportunity. And in the interest of optimize the time and my message I want to convey, let me read out a draft. RSM is a complex dynamical system. We implemented sample entropy, which combines dynamical and information theoretic approaches to understand variability patterns over different scales. Sampling is a function of embedding dimension, level of tolerance, and length of time series. There is no general consensus to determine it. Therefore, requires therefore an intense and meticulous efforts with several concept revisions, which lead us to come up with an empirical approach guided by phase space embedding. This might be a best possible way to determine a sample parameter for hydrometeorological time series. We found that sample entropy is consistent with rainfall entropy over seasonal scales. However, differences surface as we look into lower time scales. We examine contrasting years, namely excess and deficit, and in particular found that during deficit year, sample entropy markedly differs from that of rainfall. This could be attributed to emerging correlations with soil moisture, which persists for longer time scales. This peculiar behavior, known as soil moisture memory, along with increasing participation of other regional atmospheric forces, may govern the soil moisture dynamics during deficits. In summary, SAMPEN holds potential to identify patterns in RSM and thereby improve the understanding of the regional extremes. Thank you.
The next presentation will be by Priyanshu Gupta. Is here. Priyanshu is here.
He should be online, but he's not online.
Okay, if no, then we'll go to the first one, that Kati Jason. Okay.
Kati is not there, but her message is there. So just
you want to play or?
Yes, is requested and we play.
Okay. Oh, okay, that's fine. Let's start. So I request everyone after the session, please visit the poster sessions D8. It will start from 10. I think it's already time is up. So, yeah, but it's only 10:11, right? So I request everyone to visit the poster session and interact with our poster presentators.
where in the
It is in Barameer. I will take the tea. No worries. Okay, we can check it online.
Sound is not coming. Will require 2 minutes.
You can put the computer sound. Just play from the computer, just change the mic.
Space evaluation of CNET5 global climate model simulations, analyzing results from the CORDEX 44 ensemble of regional climate model simulations, and distilling these into a set of plausible scenarios for future changes. Key stakeholders were engaged with throughout the process. Several dialogues and workshops were held, bringing together hydropower owners, engineers, and policymakers with climate scientists and impact scientists, where project outcomes were discussed in a series of interactive sessions. The references section of the post contains details of key publications and reports from the project for further reading. Thank you very much for your interest in this work.
Okay, thank you for coming our session. Okay, thank you for coming our session. I'd like to very appreciate your enthusiastic discussion and question and comments so forth, and also presentator making a very excellent presentations. I appreciate that, sir. And we'd like to move into poster sessions. Please go for the poster and some mutual interactive discussion. Thank you very much for your participation. Just a second. So I request Dr. Koji Dairapu to kindly felicitate Dr. Sridhar Naika, who is the session here for today's program. Thank you very much.
Yes, just a moment.
Yeah, please receive. Please receive. Yeah.
Just a moment.
Yeah, just a moment. Yeah, and I request Dr. Mandira Sreshta to kindly felicitate Dr. Suman Maiti for hearing this session. Yes, sir. Thank you very much. Now we can all move to Varami Hall.
future of CORDEX, the future of CORDEX activities. And again, we are going to start with some triggering issues. I will very much like you to pump in and provide your thoughts and get your feedbacks here. And then we have a break, and then there is a session, CORDEX in Action, which will be for those who are interested in joining. So I have one announcement. Yesterday we missed the remote control of this equipment. So if in any case anybody took it and didn't realize that they have it, please return it back, because we need it to continue with the presentation. That is what we are not getting. I would like to invite Teresa Cavazos and Grigory Nikulin, two of the scientific advisory team members, CORDEX SAT members, and they are going to wrap up on the insights of sessions C and D. Teresa, for session C, please go ahead. Thank you.
Thank you, Silvina. Good morning. Can you put the insights for C1? You're here. Thank you. Thank you. So I have the top highlights for the joint session C1 and C2 for impacts. One of the highlights is that CORDEX has been useful for climate impact assessments and adaptation plans, but for risk management, some indicators and high resolution data are still needed. So far, high resolution assessments have been done only for individual cities or regions. And how can we prepare for the next unexpected extreme event? The other point is that complex coupled regional models for local scenarios have been used with some success in some coastal and sea regions to analyze water pollutants, heat waves, sea level height, and for example, in the Himalayas have been used to investigate the velocity of climate change for vulnerability studies. The other point is that ensemble members of individual or several regional climate models are needed to understand and to reduce present and future climate uncertainty. Storylines are helpful to understand different model scenarios and physical processes, and artificial intelligence and emulator can help in data complexity. So what can be some of the future challenges according to the impact groups? Well, to facilitate decisions, it is very important to produce reports and data that make a difference in decision taking. How can we transfer useful information to society? And in this sense, more integrated or more engagement of our community is needed to arrive and do risk assessment and adaptation studies that are useful for society. In some of the sectors, for example, the renewable energy industry considers future weather and climate a threat to wind energy expansion. Thus, high resolution studies and high resolution data are needed. For example, kilometer or less climate model resolution data, high resolution in the PBL, data at 1 meter height, and surface variables such as roughness are needed. In other sectors, such as crop models, evapotranspiration, wet bulb temperature are also needed. Of course, we know that these variables can be calculated, but these sectors want these variables as output of the simulation. So The other point is that multimodal regional climate simulations are needed at finer resolution, as we have been discussing in this conference, less than 25-kilometer resolutions on some domains and over mountains, for example, the Himalayas or some really sensitive regions of the world. More evaluations are needed to analyze model biases. In this conference, we have seen positive and negative biases or something, but we haven't heard much about what are the reasons for those biases. And last but not least, it is very important to improve and to apply more coupled regional climate models, both in the continent and in the oceans. Thank you.
I don't know. Thank you, Tere. Is there anybody willing to make a comment or add some issue here? Or no? Okay, so Grigory, please. Thank you.
Yeah, no.
Okay, good morning, everyone. And I'm going to present insights from the D session yesterday. And first of all, I really would like to say many thanks to all D session's co-chairs because they provided their contribution timely. Already yesterday, everything was ready. And altogether, we had 9 D sessions yesterday. And of course, they have completely different topics. So we're going just one by one with a very, very short overview and basically the main messages from each D session. So the first one, it's about coupled ocean regional modeling. And basically, we all know that there is a lot of interest and demand for this topic in different regions worldwide. And there is a proposal to define a new task force for some kind of international coordination of all ocean-related activities with sea ice, biochemistry, and so on. And basically, yeah, we see if there is a demand from the community. So basically, maybe just to start organizing such kind of activity with a mail list and so on. And for D2 session, it's about the polar regions. So basically, there is a big project in the European Union, Polar Res, and they are producing new simulations with really high resolution for the polar region, 0.1 degree. And also there is a work ongoing on a kilometer scale simulations, but of course there are many challenges to run such kind of high resolution simulations in the polar regions because regions are really large and there is a problem with the observations and with many processes and so on. Yeah, and basically there is also a new model intercomparison initiative led by Polar CORDEX people in collaboration with these other projects. And for the D3 session, it's climate projections for islands. And basically, we all know that this information is still missing because we're getting many requests from many communities to provide high resolution climate data for islands. Yeah, and basically somehow we should address this issue in the future. And already there are some pioneering projects that are working to provide this information, maybe for island scale climate, but of course it's maybe just for very, very small regions, but in different places worldwide. So basically there is a proposal to establish a new CORDEX flagship pilot study for islands. And D4, so this session was about climate services and best practices for FAIR principles, for data and so on. So of course, we can see that there is a very wide range of users, stakeholders, and all of them have different needs. Yeah, so of course it's because we quite often can hear that basically CORDEX should provide maybe climate information and questions, should we do this or not, or should we just cooperate with climate services? So this was maybe one of topic for discussions here. But of course, it's very difficult to provide some kind of standardized output for all climate services because it's user dependent, it's clear. But also there were many discussions about how to provide data, how to access CORDEX data by different ways, through ESGF, through new approach under development ESGF2, or maybe using commercial cloud services. Okay, D6, so it was about urban climate, and we see basically many activities within CORDEX, especially with the urban FPS, with a very good progress, I would say, looking at the high resolution climate modeling for urban environment. And basically within this FPS, a number of RCMs have already been developed and tested with sophisticated urban schemes. And basically we can see that signal at urban scale already can be seen even at a relatively coarse resolution, 0.22 degree, but of course it's supposed to be seen when we're moving to CP scales of few kilometer resolution. But of course it's mainly for temperature now. And the 7th session, it's about training on how to compare bias-corrected regional models, and combine them with the empirical statistical downscaling, robust future climate projections. And the main message is I see that basically hands-on workshops can be very useful to demonstrate new models, new codes, new approaches. And also one issue is usually it's making data more accessible for creativity and greater scientific possibilities. Then we're moving to session D8. It's extreme events, observation and modeling. And basically this session focused on improving our understanding of the changing pattern and trends in extreme events and all related issues with when we try to project these trends in these extreme events. And this session also explored physical processes underlying different kinds of extremes, basically focusing on our knowledge of the causes and mechanisms. Then we have session D9 with the aerosol impact on regional climate. And we now see that aerosol can have very important role in regional climate, especially in trends, in temperature, in shortwave radiations. And of course, the lack of transient aerosol in our regional climate modeling simulations may lead to some kind of, as it was formulated, reduced value in RCMs, but simply speaking, it's basically differences between the global driving model and regional models. And 2 RCM tracks are foreseen. So one, it's fast track, basically using climatologies, and a slow one when we're trying to implement a fully interactive aerosol in regional climate models. But basically, of course, it's can be a bit heavy task, but a lot of work is ongoing in this direction. And also there is a suggestion to establish a process-oriented multi-region flagship pilot study on aerosol and aerosol cloud interactions, because now we have only one FPS focusing on aerosol in the Mediterranean region and generally in Europe. And now we're moving to our last this session. It's concept identification of global warming levels, GWLs, for regional climate services. So because almost all climate services working now with providing information for different global warming levels, but of course they're using a little bit different approaches, and of course it's supposed to be adapted for user needs. Yeah, so defining a single approach for all such kind of work, all climate services, it's maybe not reasonable, because always there is a difference what users need and so on and so on. And basically suggestion is always to provide metadata information about degrees of warming compared to what reference. And we know that, yeah, it can depend on what reference we use. And also which scenarios have been used to derive information about the global warming level. And basically general guidance in terms of a review paper could be very useful for this topic. Okay, thank you very much. So that's all. And do we have any direct comments from the D session co-chairs? if it was reflected what you actually provided or not. Okay, so I see basically no comments. So I hope that all are happy with this presentation.
Thank you, Grigory. Now we are moving to the discussion. But we need to put some slides. And while we are preparing for this, I'm very glad to hear from this session some of the interesting proposals that are also part of the discussion we are opening now in terms of the future. Several these sessions propose some new flagship pilot studies, so it's worth to discuss this with all of you. Sorry. Thank you. So this is something that we would like to discuss with all of you. And other issues also came up in the insights from the different sessions, the insights from A, B, and the insights that Teresa discussed today from C. Also related with what we do with the models, how we continue with this coordinated regional climate modeling, including ESD experiments. So to organize a little bit the discussion, we have gathered some thoughts together with Daniela and together with various SAT members here on the main issues that we would like to discuss with you. Let me first mention, I didn't have the chance to put it in the slide, but you all are aware of the protocol for the CEMIP6 CORDEX simulations. There are some information on what is available, what is planned, what is going to be prepared in the next few months about the planned simulations. And there are quite a number of simulations already finished for most of the different CORDEX regions. So the coordinated continental scale experiments are ongoing, and there are lots of simulations already available for the different regions. You can check that in the CORDEX website, and the status of the simulations is being updated once the groups updates information on the simulations. So please go there to check it. So now we can now go to our list, Daniela. One of the main goals of CORDEX is to continue with this continental scale coordinated experiments, but we cannot just run models and provide those model outputs to the community so they use it, and we don't know whether the models are doing well or not. So one of the thoughts we have here to discuss with you is we really have to work on improving the quality, or assessing first and then improving the quality of our models. So do you want to jump in, Daniela?
Yeah, thank you very much, and good morning also from my side. So first of all, let's have a bit of a look at what we heard this week and what is expected. And I think this was a great week, and we heard very interesting talks. I'm sorry that I could not be in parallel in all these sessions. They must have been very interesting. But through the entire week, there was one topic that was, of course, on the relevance of the continental scale experiment, and CORDEX is coordinated downscaling experiment. So that's what it says, and I think we will not change the name because this is really important. So we thought a little bit about where are we with this, and what is ahead of us. And ahead of us, of course, is an increasing demand on medium and high resolution climate information for today and the future. And with this, and we saw it from the C presentation, a demand on specific variables or space and time resolutions, which we probably haven't really evaluated over the last 20 years enough. So we would like to discuss with you a little bit how we can make sure that we fill this demand, answer this demand with high quality information. In addition, we see global climate modeling approaching more and more CORDEX space and timescales, which will solve parts of Rasmus' problem with a low number problem or little number problem, or how it was called. So we will get more and more simulations of different kind for which can be analyzed. And I think it's also time to make sure that the regional climate models are at least on equal quality or better, and because they can take into account the experience on the smaller scale phenomena. So that's a little bit on this first topic, which we would like to discuss with you now. Maybe we start with the quality a little bit. The question here is, I would say there are two questions, and I would like you to separate this. So let's first talk about the 10 to 25 kilometer grid scale, not about the convection permitting first. So we do this in a second step, because that, of course, also needs an evaluation effort, but that's the second part. So if you now think, and Filippo said it the other day, do we have reasonable large ensembles? Do we have trustful ensembles on all continental scale domains or all the CORDEX domains? Do we want to enhance CORDEX core? If you look into the website Silvina just mentioned, Africa does not look very good. So we checked it. You have 48 pages of website. You have many, many simulations, but very, very little for Africa. And also for other domains.
Let me jump in. South America has only one simulation that is not even really CORDEX compliant.
Yeah. So maybe we can hear your thoughts and voices on this first. We need a few volunteers who are young early career scientists, would like to stand up and walk around with a microphone. Of course, also say something, but I think we need some volunteers here to pick up your voices. You can share the burden after 20 minutes or so don't worry. But we have two microphones, and would be nice if you could help us a little. Yeah.
Thank you.
Erika, please. I come to you. Erika, start. So the rapporteurs are perfect. Thanks.
I didn't really get the last point. So what exactly did you check, Silvina, for Africa and South America? The simulation that are available or what?
The CMIP6 planned downscaling.
The planned one. Okay. Okay.
What is available is very uneven distributed between the different domains.
Okay. So this was the first question. And speaking about how to carry on this, let's say, standard domain, can we also include the idea of having this multiple resolution, keeping out the convection permitting, like having an ensemble that can go from 10 to 25, even to 50, for including all the group and to be inclusive? Can we discuss if we want to do this instead of just fixing one resolution like 25, but maybe there are some groups that can go also 12, like we did in Europe. For example, we are discussing with our South American friends that maybe we could go 12 kilometers for South America now, if possible. So can we open that?
Yeah, sure. Someone.
So I'm also very attached to the quality of the regional climate model. I think you're completely right. If we cannot prove that regional climate model are at least better than GCM over a given area, we will disappear very soon, at least for those continental scale. So on this aspect, I think in my very first slide, I had 4 axes, and one of them was physics development of the model. I think CORDEX did not put enough emphasis on the model development. In CORDEX, let the different modeling group developing their model without coordination of that, without rewarding that somehow. And this may be something we could try to change. And there is another aspect that we did not focus too much in this community is model tuning. So the GCM community published paper, multi-model or coordinated paper on tuning. We just do our tuning on our own. And there are new now machine learning based methods for tuning the model that are quite efficient, I guess, and we could share the good practices of the different groups. So for example, I realized that Cosmos LM, they are doing a kind of an automatic tuning, but I realized that very recently. So something that is not completely shared as an experience in the community. Then on the continental scale, I guess that another way for improvement is a complex regional climate model coupled. So adding component that even the GCM do not have, for example, because we have, component we can refine locally. And then I agree that the connection between the ESD or emulation stuff and the regional climate model is one way to produce very large ensemble at continental scale, and then to solve the issue of the too small number of run.
Yeah, thank you very much. I think why are we picking up this year is when we started in Prudence, or in all the other in the other activities, we had on the 50-kilometer resolution, we had large validation activities, joint activities, and we still have this. So I think we are in a relatively good shape, but nevertheless, if we want to go to multimodal, and I fully agree, we should have several. I mean, I'm not only talking about 50, 25, and 10, but I wanted to exclude the convection permitting because it's for the moment for the discussion. I think that's important. I was thinking about enhancing again kind of a joint evaluation. You can call it also tuning or whatever activity. But with, I would say, a bit higher benchmarks. So I really would like to see, being honest, a strong step forward in the quality. And either you can show me that the quality is in the systemic parameters is great, and not only in 2 parameters is great, or variables. I think we really should push for kind of a really step forward. That's why we also put here the budgets again. I haven't seen much on the budgets in the last years. And on the different resolutions, I think we have to look into this again. And that's why I thought it's important to bring this up here. Stefan. I don't know if you raise your hand, you have to wave a little. Okay, good. There's one. Okay, thanks. Maybe you can bring the microphone to this person over there.
So luckily enough, my flight was canceled at 2 a.m. last night, so I get to be here now for this discussion, which is great. So maybe one challenge we face in CORDEX, which is different from CMIP, where everybody is in the model development game, is that not everybody in CORDEX is in the model development game. So can we see a show of hands? How many people in this room are directly involved in model development? Okay, yeah. So maybe one way to deal with some of the issues that we're discussing, and also I think you can put the tuning thing in here as well as a dedicated FPS that focuses on on these improvements. And then the simulations don't have to be super long. So the bar to entry isn't quite as high. It's not like you're saying we have to do 50-year, 100-year transient simulations to assess these improvements. I don't think. Maybe for some of them, for things like trends, we would have to do longer ones. But if we focus on the parameterizations themselves, then maybe not so much. And that could maybe help with this, help in this focus towards quality improvement that you're asking for.
Alessandro.
Yeah. Hi, everybody. Excuse me. I am very glad that you mentioned the domains, because I had a very provocative talk, so I don't feel so guilty now that you mentioned it. And okay, I thought that I think is quite provocative, so don't take it personally to everybody. It's just I like to play the devil advocate. But okay, a little backstory. I've been involved in CORDEX since its beginning, 2009, I think it was in Toulouse. I've been for a while a model producer, producer data, and now I'm avid user of CORDEX data. I use it for impacts and to provide policy. So that's what I do. And I really thank you, the community, for producing an increasing amount of data for Europe. And then I remember the CORDEX aim that, if I remember correctly, is to produce high resolution projections for all the land areas of the world. And I don't think we are doing this anymore, because we are not producing high resolution, because 50 kilometers is not high resolution anymore. And we are not producing runs for all the lands of the world anymore. You mentioned Africa. I think that Africa has no single plan simulation for CMX6. So my question, provocative, is why are we running simulation number 2,476 for Europe at 10 kilometers and nobody is downscaling Africa? We are a community, but I think we are a community of small communities. They don't talk to they don't talk to each other. EuroCORDEX is very advanced, but others are not. And so my vision, or what I think should be the vision of CORDEX, should be to provide a 10 kilometers ensembles of simulation for all the regions of the world. I don't know how this can be done, but this would be my thought, provocative thought. And I think the only way that CORDEX 1 was so successful is because people was forced to do Africa. And this is why now we have data. If you leave people to do what they won't do it. So thank you. Now I can sit back and enjoy.
All fine. And I don't like people let to do what they want. So that's why I'm often people talking to me way too pushy. So, but I fully agree. And I'm glad you raised this, because I think this is, and we discussed it when we were sitting yesterday afternoon. That's why we started with this coordinated downscaling experiment idea, the discussion this morning. And at the beginning, Africa was mandatory. So the African domain was mandatory. And it worked partly to persuade funders from non-African regions to pay for this. It worked quite nicely at the beginning, I would say, but that has changed. And I think it would be really great if we, and that's why I also mentioned the CORDEX core again, that's 25 kilometers for all land masses. not 10, but as we know, there are only 2 modeling activities involved, and we have many more models available here, and modeling centers, big modeling centers. They're much larger than my capacity in my center is. And so I think it would be, of course, very important to get a strong voice from the CORDEX community as a key message to Kigali that we would like to enhance and try to achieve a reasonable amount of simulations. I would not say as many as over Europe, but a reasonable, that's why I say reasonable, but more than, I would say 15, 20, for all domains, or land domains. And I see already faces of some of the modeling centers here saying, we will not do this, we will not do this, we don't have the funding. So what can we do? So if we agree here on a message to Kigali to say this is of highest importance for societal challenges, and we need a support similar to CMIP, to whatever, and get a kind of a WCRP endorsement on the higher level for saying, yes, this is important on the way to the impact adaptation, but also to the finer scale for science, so for both science and application, we might have a better voice talking to the funding agencies.
Daniela,
yeah.
I would like to add to this, Neil, that if we don't do this, the global models are doing it for us. So we are not needed anymore because global models are going to the convection permitting, not for this next 5 years, but they are going there. The EVE initiative is going to the convection permitting globally with different global models. So, and we will disappear. So we need to provide some useful outcomes to the community that makes us to be relevant as we have been since the beginning of CORDEX, and mostly after the CORDEX core, in which all continental areas had a minimum of 6 simulations to have a fair comparison among signals and uncertainties. So who's next?
Yeah.
Bill?
I want to draw your attention to 2 regions. One is the high mountain Asia. The current CORDEX simulation that we have, that is like in temperature, they have at least 10-degree difference with observation data. We analyzed that models, the 3 models that we have, and the last that Motasim performed the simulation. So one of the efforts that is going on now with the Tibetan Plateau flagship project, they are in the process to run some model, and we will validate that model maybe soon. But that is the important area that because it's feed with multiple countries, and most of the policy of those countries is focused on that region because of the glacier melting and the water availability. And the second thing is about the Central Asia. In Central Asia, I wrote in one email, and then I said that it's the most ignored region with the CORDEX because there is no capacity building efforts so far. The research paper that I downloaded from internet, almost 30 to 40, it was from Europe, and all the European scientists working on this. So there is no one that we build the capacity building of those people, and they come with their own research, indigenous research, and they can do something with this. So this is the kind request to you may also in the next WCRP meetings to focus on that region as well. Thank you.
Thank you very much, Bill. Just before you start, I would like to see, is there a question from Pune, and who is looking at the Zoom? questions? No? Okay, good. You let us know, you just wave when. Okay. Good. And can you read the comments maybe? Yes.
Yeah, we have a comment from Christian Steger, and he said, we need to define what we need by quality. There are many, many options. If it is not defined, there is no target to work towards. And he also said, the problem is that we turn the RCMs, usually with error boundary conditions. Once you use GCM data at the boundary, things change again. So a returning for each GCM would be necessary, but then you get additional differences in the simulations. I don't understand what you mean by that.
We will also save the comments for the protocol for later. So now we have Bill, and then we have Erika, and then Andreas. Is it Andreas? Yes. No, it's you. Okay.
Yeah, a couple of comments. One, there are GCMs that are moving towards convection permitting resolutions. There is the high-res MIP project, and they had a couple of small workshops. I think it was last week or the week before. Their median resolution in the AR6 was about 35 kilometers. They are very interested in comparing the simulations they're doing now with what CORDEX is producing. And so I would suggest that there be some kind of an outreach to them to try to set up some of that comparison, which would be very useful, I think. And the other thing is to recognize that the vast majority of GCMs are not substantially increasing in resolution all the time. And the AR5, the median resolution was about 160 kilometers, and the AR6, for the non-high-res MIP models, the median resolution was about 130 kilometers. And that trend is comparable, if my memory is correct, in how things changed from the CMIP, the previous CMIP that was in the AR4. So there's still going to be a great need to address that quality issue of RCMs at the continental scale. And I want to make sure we don't forget that there are a small number of GCMs running at much higher resolution, but that's not going to be the vast majority. It's not what the trend has been over the past 10, 15, 20 years.
So just to echo that comment, so the GCMs are coming. They're going to be doing convection permitting simulations, but they're not nimble. So they'll be resolving a single scenarios. They're not able to capture extreme events, particular extreme events you might be interested in. I think this community is really uniquely placed to be able to downscale individual extreme cases, looking at the role of internal variability. So even when GCMs have arrived at that kind of convective permission scale, I think there's a real value for the regional modeling to be able to explore the ensemble, which they will never be able to do. So I think we need to kind of believe in that role, and we're evolved into that role. So.
Yeah, thank you. I think that's really important. I try to push us a little bit towards the benchmarks for the global, for the GCMs on the fine scale. So, but in order to be there, we have to be on a high quality and we have to be on a global scale. So Erika, please. And then I think there was one here, Tamas, and then we slowly move forward.
Back to the point of Silvina, I think it's very important that if we want to make it, for example, to the next report, since we have done so much work to get the CORDEX in, we have to do a step forward. So we have to increase our resolution and provide a full coverage. This was the strength, the reason why we made last time. But it's not the only thing. We also have to produce literature. So it's true that we provide the run for all the continent, but except few groups, there are not so many publications done in all the continent with this simulation. So I think the commitment is also to engage with the community and have a plan to use this data before that is too late, to produce the publication too, and to fill the literature gap that we have highlighted very well in each of the content you can find. So I think the good thing is now we have time, because when the CORDEX core was launched, it was already too late. It was a big effort, we know well. I mean, it was a big rush. And so, like, yeah, we made it, but we made it just because COVID helped a little bit with the time, because there was a delay of the deadline. So I think now we have time, so we could maybe better understand which are the barriers for the group, for the other modeling group, to commit to this kind of simulation, and then maybe coordinate, like, for example, just speaking with Samuel, for some of them, the problem is the commitment to deliver the data on the SGF, because the workload is a lot, because the SGF node is not sustainable anymore or whatever. But I mean, we can, you know, like, try to do this, because otherwise it's true. We have made last time, we will not make this time.
Yeah, thank you, Tamas. And then I would like to bring in 2 more suggestions here.
Well, seems to me we are a bit oscillating between the topics, actually between quality and strategy experiments and capacity. My comment was mentioned for that the capacity issues that we had yesterday in our V6 urban session. One contribution of James Christoph Lennart. I'm not sure he's here and not saying anything, but he actually provided nothing on urban stuff, but he provided a nice assessment of resources which are necessary for some simulations for Africa, or intended simulations for Africa, to have really some ensemble. And he compared it with the available resources on, say, big cloud providers like Amazon and maybe others. And I recommend his contribution actually to have a look, and maybe that might be some kind of message for Kigali, for WCRP, to try to find the ways to these possibilities to provide resources for this computation. Thank you.
Yeah, thank you very much. Just a second, Filippo. There's one thought which we discussed on Monday. Someone brought it up and said, if for some groups, and I would ask groups in a few minutes if you would commit yourself immediately. I know you cannot, but at least I would like to see if you would like. So how many groups would join this kind of continental scale activity? But before this, there was a point until what is the time? What is the number of decades which we are running in the future? So are we really running until 2130 soon, or are we running until 2100? Because that's not 10 decades anymore. So we are close to 2030. So we could have an emphasis on, let's say, until the end of the century, or even for some activities, maybe until 2070, which makes the workload and the computer costs less. And with this, we probably could get more ensembles. And I would state here that even if the simulations are shorter, they will be a big benefit for the continents and on the continental scale experiments. We will miss some sectorial activities, yes, I know, but it would probably deliver a push for more simulations for some of those blend continents. Domains. Filippo, please.
Yeah. Well, first of all, I agree with Bill that I don't think CMIP 7 will have a 10-kilometer global models. In reality, the simulation of the scenario runs is not increased so much. So I don't think we should worry about that. By the time GCMs will run to 2130 with 1-kilometer models, climate change will have happened, and nobody will worry about this anymore. I didn't say this anecdote, but 30 years ago, somebody thought that regional modeling would last for 5 years because global models would get there. So this, I don't think this is an issue. I think a big selling point should be, and I think WMO is very receptive of this, that when you have a regional model, you don't have a lab. You have a community that is using that model.
Okay, for example, in our case, it's not like we did all the runs. The South America runs were done by Rosemary. The America run, North America was done by Melissa. And this community building, first of all, you share the load of the simulations. And second, I think is a really big selling point for WMO or WCRP. I remember in these meetings, this was really big. So I think it's very important to set the protocol, decide resolution. 10 would be fantastic. I thought that we could do 10 in the last report, and then, okay, it was not possible, but 25 was already great. I think, you give two options, then you give two options of time scale, maybe 2070. Many people are just interested in the next 50 years. 2130, I think it's a bit far, but once the protocol is there, the key thing is to convince the communities of the WRF users, the Cosmos CLM users, the RegCM users, the REMO users, that there's a community effort. And this really will be a big selling point, I think.
Yeah, thank you very much. I think that goes into the direction with the papers, and also it complements nicely Stefan's question, who is a model developer in the room. So we have many model users in the room, and I think if we think a little bit about a strategy, we can immediately think about the strategy for the paper published. So we had Teresa and others pushing for the physical phenomena and the knowledge behind the physical phenomenon. And I think if we give it another go directly with the let's say the user and the data analysts community in a kind of a strategic way, so that we do this joint coordinated effort and say, okay, from each of the continents, we would like to see at least 5 papers, and have those laid out at the beginning, and also agreed on the leads, and make sure that we can bring in as many people from the community as possible. So these are kind of, first ideas. No? This needs to be refined, of course. Please.
Joseph Sictus. So I have 3 points. One is you're saying that we could run to 2070, but I don't think that we need to run historical period from 1950, and you could run from 80, and that way you could go to over a century and you still use same compute resources. And so that's it's more practical and more useful in many ways, because I don't know whether we're going to learn that much if you have 70 years of historical simulation. So there's a lot of compute going there, 50% to do historical. The second one is from practical sort of application. I work for state government in Queensland, Australia. People really want high resolution, the decision makers, because a lot of people live on coast in cities and whatnot. So my view is that if you want to be different from DCMs, we should really aim at 10 kilometers. And for places you cannot because they are too big or whatever, like Africa, you could do 20. And that way you clearly sort of ahead of global models with resolution, and you're also producing something which people can use at sort of a local scale. 25, it's a bit too hard, too sort of a coarse and not very useful for decision making. The other issue I have with the current protocol is that we define these 2 scenarios, 2.6 and 7, which is sort of bracketing the things, but there is nothing realistic for policy making 4.5. And so I think we should really think hard, what is the most realistic scenario we likely to experience, and run that as a priority.
Yeah, thank you very much. I know, Erika, you get the microphone in a second.
I also have a question.
Yeah, just a moment. We have a reply from Erika. We have first a comment from myself, and then it's up to you. My reply first is from a purely physical point of view, I don't like 10-kilometer resolution. This is the worst resolution we can pick. I don't know, this will help us a lot for evaluation and being good. So we should think about this a little bit from a purely atmospheric meteorological point of view. And so 10 is not a good resolution. Now, Erika, please. Yeah. Erika.
But this just in Europe, we have 12. So it's a bit, I mean, why don't you like it? But this we can discuss later. Now, my comment is more about the strategy. So like this scenario and how long the run should be. I think here we really could take advantage of this global warming level framework, because if we decide that it's important for us to cover the first 3 global warming level, then the length of the simulation can be different according to which GCM you are downloading. And this could be a big help. And also we don't need so many scenarios, right? Because you have to make sure that you are covering the lower global warming level. So it would be a certain point is obsolete to run also the 2.6, because if you run the global warming level, if you run the GCM that is also the global warming level 1, 1.5, and 2 is enough. So maybe the protocol could include this variable length of the simulation, making sure that each of the simulation will cover at least n global warming level, where n has to be decided if it's like 2, 3, and which they are. And this could help.
Okay, we have now a comment from Pune, I guess. I would like to move then into the convection permitting discussion. So like to wrap up this after, please go ahead, Alessandro. We have first one in Pune and then it's Alessandro. Alessandro, first the Pune one and then it's you, please.
Yeah, Daniela Pankaj here. Actually, I'm attending from a little bit far, so I just got a chance to speak because I was unmuted. So one point just which you asked initially, that obviously we would like to go for 10 to 25 kilometer modeling, for at least for South Asia I'm talking about. And we also, you very rightly said, we don't have much ensemble, which we can be used for making reasonable informations for this region. So that should be encouraged. And another point is that, which I think Filippo also partially touched, I think it was that we should have somewhere who have more facilities should do some kind of core simulation for all regions, not obviously not for so many simulations, but at least a couple of core simulations, core domains for simulations, so that at least for the domains we have some simulation, so that and some regional, so that at least a handsome set of runs are available for those kind of studies. And another point probably does not fall in this, or maybe you will take it up later, because if we go up to 10, 25 kilometer, and then this data all, if we have good some number of simulations, will fall under big data kind of thing, and then maybe a supplementary thing, at least where the much more computational resources are not around, can go for this AI/ML kind of thing, and particularly downscale the information to much more finer scale to a kilometer or so. Thank you.
Okay, Alessandro, please.
Yeah, just a very quick reply to Erika's idea of the global warming level, which is fine as long as we define a definition of global warming level for regional application, which is the same for everybody, because now there are so many different ways to find it, which is fine. So first we need to decide how to define the global warming level. A second thing, that's true, but policymakers still needs data in 2050, and also 2-degree warming in 2050 is different than a 2-degree warming in 2070 for a policy point of view. So it's not really so simple.
Okay, so I think there's a lively discussion ongoing. I hope you agree to my spontaneous summary that CORDEX core type experiment is important, needed, and we would like to try to get it going. So we have to make sure that we find the resources. I count on the strong modeling centers to be willed to find the resources with me. I'm not saying you have them. I already have a few ideas what we could do, but I think that is something we can discuss later. I would also hope you agree that it is good, what as Erika and Filippo pointed out, to have in the strategy not only the continental scale simulations being planned, but also planned the community effort on the data, on the analysis, on on running the model, on the papers. So immediately while setting up the simulations, think about the phenomena which you would like to analyze in the region with the new and the old CMIP data. I mean, there is data available. I think this is something which we can also pick up again. And I also think it would be good to approach the 10 kilometer roughly. But as I said, this is a tough thing. But so we think about different resolutions, depending a little bit also on the length of the simulation, and we also agreed, hopefully, on enhancing our joint evaluation, a little joint evaluation effort. I mean, if all the models are state of the art, I'm fine. Just show it. So that's so I think that's something which we also, I would like to, these are first ideas. I mean, and you can all send emails and we will keep working on this. I would now go to the convection permitting stuff. And I would also like to come here with urban and high resolution land management issues, coastlines, low-lying islands, small islands. So everything where you need a, let's say, kilometer grid, not more than a kilometer, maybe down to 10 meter in the canyons of the streets and less. I think this is something which we should discuss, also from the evaluation point of view, as we did before, and from the scientific point of view very strongly. And I would like to hear a little bit your views on the connection to the different communities which are experts on those scales. And I say this because we do have in WCRP and WP people, we have seasonal S2S, sub-season to seasonal scale experts. So we do have GVEX, and it's my favorite. My favorite is GVEX with the continental scale experiments in the end of the 90s or middle of the 90s with tremendously valuable observational data sets, and they have been made to understand the budgets, the energy and the water budget in a dedicated region. And the observational experiments have been set up to do this. So the data are available, so you can go to your model and compare your simulated water budget to the observed water budget at that time. The data is still valid, even if they're 30 years old. So I think when we come to the convection permitting, I think we have to look into the evaluation of mesoscale structures. I'm thinking here about variability of mesoscale variability of water vapor in the atmosphere, for example. So these, what are we doing here? Because this is now new land. You did great work in the FPS. You connected in the urban very nicely to the urban climate modeling community. Can we enhance this? And what are the plans in this? Because I doubt we can just do it from global to local and miss this. And maybe we need a WCRP initiative on this, which is cross-cutting through other core projects.
Actually, there is a new lighthouse activity in WCRP, which is devoted to budgets, water and energy budget. Of course, based on global models up to now, but we can also make some inputs on that from the regional modeling community. Yes, please go ahead.
Yeah, here is the question or comment from Pune Hub.
Okay, Pune, go ahead.
Yeah, I think the CPM experiments are, I think, extremely important. Especially South Asian domain and especially focusing on the most complex regions such as Himalayas and Hindu Kush regions. I think most of the models, right, from CMIP to reach CORDEX models, and still they face a lot of issues or challenges in getting right picture over this region. Relatively, reasonable framework needs to be developed so that, especially mesoscale convector systems and cloud burst kind of stuff can be, can be simulated well, and then understanding of those scales can enhance the predictability and enhance the fidelity of the models. So maybe Philippe or some other experts can comment on it, how this can be, this kind of frameworks can be developed.
It's Sanjay there.
Yeah, I am here.
I'm not sure.
The question was from Dr. Raju Attada from Icrc Mohali, who is a participant here. So did you get the question?
Could you please repeat your question?
Okay. Yeah, in short, especially mountainous regions such as Himalayas and Hindu Kush, what kind of frameworks at the CPM's experiments scales can be developed, in short?
So you suggest that we when it comes to the convection permitting, that we are looking at complex regions, for example, mountainous regions, as you are suggesting, and also try to look at features which are of interest for different areas which have similar features. I mean, monsoon, for example, I was talking about. It's too early for me this morning. Sorry for this. So I think this is a good point, and we will take this up. And I think the Himalaya region, the Andes region, they are already in our minds. And maybe if we can organize an effort, a joint effort, I would strongly recommend to have the mountainous regions in there. But there's also a huge local community with a lot of knowledge on this. So we have to make sure that we connect. So it's Samuel and then Stefan, I guess.
So for convection permitting model, I think now it's time to go further than just the FPS. So I would say it's time now to prepare to have a very ambitious vision and prepare convection permitting model at continental scale, which is a very, very far objective. Okay, but we need to put the stones on the path. So this could be defined. I mean, first of all, having a coordinated protocol and a way of running and a way of sharing data. So building on the FPS is taking the experience of the FPS and going one step further. And then one possible organization would be to define convection permitting small domain within the existing CORDEX domain, and then growing with time. So extending this domain with time. This is a bit at least what we are thinking in Europe. So we started with the so-called alpine domain in the FPS. Now we have two much bigger domain, and we target to have the whole Europe at 3 kilometers at some point. So something like I don't know the word for Perus, or like Russian
nesting.
doll.
That's the word.
Let's
It's
say
nesting. It's
nesting. Yeah, nesting one in the other.
Yeah, just a second. I think this is important. We will bring this up and also think about it, such a coordinated activity. I think we also need an evaluation part in here, and I'm particularly worried about the provision of the boundary data for the very high resolution domains, because we have to think about this beforehand. So when we think about symmetric simulation, we probably need higher output in dedicated regions where we do have a nested simulation in it, or another nest in it. And I would also like to remind you to come back to the issue with the resolution jump on the boundaries. It's not gone just because you resolve convection.
Let's get a bigger domain, give it more time to adjust. Yeah, you're not going to find me disagreeing with Sam's ambition here, but and I think one of the solutions to this is similar to our solution to get the fully global coverage that we were discussing on the previous point as well. And I'd like to thank Alessandro for bringing that up, because we really should be doing better than that than we are. And one way to do this, I think, is to really have a dedicated, globally coordinated protocol. So right now we're doing this very much on a domain basis, right? And so, and I am fully to blame for some of that, because I have some responsibility for EuroCordex. And a fully coordinated approach to this that involves both dynamical downscaling as well as ESD, as well as advanced machine learning, deep learning techniques, so that the bar to entry is, so we have kind of tiered levels, and the bar to entry is lowered for those institutes that don't have access to a supercomputer that can run 20 years, 40 years, 60 years, however many years transient experiments at either CPM scale or, even, parameterized scales of like 0.11 degrees. And that might be one way to, to attack this. And I'll also say too that a lot of these investigations that you're mentioning are happening right now. I mean, so we've evaluated the energy budget in the FPS and the alpine domain. They're mesoscale investigations. There's many publications on those already for the FPS. There's a few already for the convection permitting third pole region. And I think that this is really a focus for these studies, is that they're really looking at the dynamics and thermodynamics, and not just the surface fields. So I think we're quite aware of that. We can, of course, do better.
Erika?
Yeah, so just to follow up the both suggestion, I think we can take the opportunity of this content at scale coordinated core that we are discussing, and attach to that what is the protocol for the convection permitting domain. So for example, just to give an example, we could commit each of us to run one convection permitting domain in Europe and one elsewhere, at least two. But we need to, as I already told on Tuesday, we need to define those domains, and not only one, including the possibility to have the statistical downscaling and also the machine learning. But we need the coordination, starting from the domain that we have today.
So we have Gabi and then Alessandro.
So you were touching also on the urban aspect. So I would like to intervene there a little bit. So I'm sorry to take it off a little bit from the strategy on convection permitting simulations, which I think is really actually crucial. So I hope we can pick that up again. But so what we saw here, actually, that it's really a growing field now. So in Beijing a few years ago in the Icrc there, we saw only a few presentations on cities, and it was kind of like we had an overall discussion. This would be nice and important. And we really went yesterday to a full session with 10 talks and a lot of posters. So I think it's really growing into the community. And of course, also the FPS urban. And what we see, of course, on the convection permitting resolution, that you have this really clear urban signature, even with a bulk scheme, although there's huge flaws. So I would not recommend the bulk scheme here in that per se. But we also see even an urban signature on the 22-degree resolution. And if we move forward, even with the standard CORDEX simulations, there is some urban that you see for mega cities. So then the first point would be to really encourage people that already, or the groups that already have an urban scheme, to actually turn it on, even on those resolutions, but definitely if we go to the convection permitting scale, of course. And then what we really see is that the land surface the land surface description is really an issue in terms of certain, we saw from CORDEX Core that certain land surface descriptions are not really up to date. So especially in Asia, Africa, they don't really represent the size actually of the cities, even how they are right now. And we're not even talking about urbanization in the future. And then also, if we look at the files or the output variable list, it's quite hard to really get the land surface description of the model. So I really think it would be good to further think about this. And of course, we also put some first ideas in the CMIP6 downscale. That's the end. Oh no, okay. Stop talking. No, and then I think the other point that was made is to connect to the urban climate community. So there's an international association for urban climate. So we really try to engage there, also be at their conferences, and the other way around, try to get them into the FPS, of course. We also have a connection to the WMO Urban Initiative. So we try to also make their stronger connection. But I do feel that we may need to touch upon the Icrc AR7 special report, which might be also a place where we really have to think how we can contribute with the CORDEX community, with the work that's already done, but also with those experts that really can provide the climate change perspective in this report, as this urban climate community has been, there's a large focus on more the meteorological aspect. So also some climate change studies, but this has been less heavily done there. So I do think there's a role for CORDEX to play and to position ourselves there. I think I will leave it here.
Yeah, thank you very much. I think Alessandro, you have a microphone.
Yeah, I have a pragmatic question about evaluation. Assuming we have a perfect protocol to evaluate modules, which we don't have, assuming we have a perfect data set, which we don't have, and assuming we want to evaluate model on process-based evaluation, which would be nice, not just mean temperature precipitation, and which we can't because some models don't provide all the values we need. Okay, even if we have all of that, and even if we had a protocol to define, okay, this model is performing well, this model is not performing so well, then what do you do? Who is going to do this evaluation? The modeling group before the data is released, before, otherwise what do you do after? If the data is there, people will use it. So what do? You flag the model, say this is not very good. You will take the model out. So.
Yeah, these are important points. I think a couple of decades ago, we did the evaluation first. And then when we were satisfied with the quality of a model, we started to do the climate change runs. And then when we were satisfied, we were releasing data. This is the same still, I hope. And so in this, I think, is an issue which you have all the time. If we now come to the convection permitting, and we have protocols for the evaluation, I mean, it's not that we are not starting from scratch. I think we should not forget that there is a mesoscale community. I don't like this convection permitting word. I think it's okay, but there is a huge mesoscale gamma community on many continents, working with observations and phenomena and modeling more on a sensitivity base, but there are papers and experience around in a community which we are not necessarily connected to. And that's why I think that is something that's why I mentioned also the NWP and others, which I think we will never have everything perfect, as you said, but there is a lot of knowledge around on local and let's say small scale feedbacks and phenomena. I see Kevin getting nervous now.
No, I just wanted to add another thing here, because when we set up these protocols, I think it is also very important that they think about like data storage and making this stuff accessible, because this is getting more and more complicated, because there's a huge amount of data that we produce, and the amount of storage is not keeping up with the amount of computing time that we gain with new computers. And as at least in our experience, this is getting more and more difficult.
Yeah, let me, you let me know if there's another question from somewhere. Let me, Peter, in a second, let me turn you slowly to risk assessments. We do not have it on our screen here, but Bart was mentioning yesterday. If we think about the continental scale simulations, we can think about it, but let us first think about which data are used for risk assessment. And how would the convection permitting inform or like to inform risk assessments? Is this, if we have this in mind, are we then providing the needed information in terms of variables and space and time scale? And are we ready to do this? And can we evaluate them before to be ready for this? Is this thought through? Do we need an extra effort here? Peter.
Yeah, it's not directly related to that, but if you're going to these convective permitting scales or like the urban scale, and we say like we need benchmarks, but like did we reach out to the like observation community in that? Because like of course for Germany I know like a nice radar data set for rainfall, which is really nice, and the French, they have a nice data set, like really on a high resolution for most of it, but like EOPS data set, I don't see that for like the convection permitting scales, as well as like for urban. Like we have lots of urban observations, but they're not really, yeah, they're scattered around. And so, but we need that not just for a single city, but we need that for all cities in Europe. And so there should be a push from this regional climate community to reach out to them and say, like, that's what we actually need in order to like benchmark our models. So I haven't seen a European like data set that we could use to validate like the simulations for the Alps there is, but it's ending at some point in time, and so we can't use it for like simulations after 2015 or whatever. So that was just my point, like reaching out to this observation community.
Yeah, thank you very much. I would like to ask the ESD community to step up a little bit here, because I mean, we talk about risk, we talk about fine scale, small scale, we talk about information, extremes. Do we need another initiative to connect the information from the dynamical downscaling, empirical statistical downscaling? Do we need a bit of a push here somewhere?
Yeah, but I will not. I was willing to state something else before going this way for the risk assessment or ESD. I think we forget a bit the increase in complexity, at least at the continental scale. So I would like to, I mean, cities is there, is one of the axes of complexity. Ocean is another one. Aerosol is another one. So I think at some point we have to engage this way for improving our model. So land use, also land use evolution, the coupling with the society somehow also, hydrology and so on. So my vision is to do this path to the complexity within the domain. So not to create new FPS, not to create new task forces or whatever, but to engage every domain toward more complexity, toward the relevant complexity for the given domain. So every domain has to define what are the components that are needed to better reproduce the climate. Can be also related to what you call quality of the model, Daniela, or quality and development. Yeah. So, but I mean, I would not put that outside the domain work anymore.
Samuel, I fully agree with your idea, but you may do that for Europe. When you look at different domains, I don't think the communities are so large to cope with convection, complexity, and all the different components we're discussing. So it may not work for the different CORDEX domains.
Sorry. Yesterday in the ocean session, there were not only Europe, there were also Gulf of Mexico people, there were also people representing the maritime continents. I discussed with the Arctic CORDEX, they're also going this way, people in Australasia. So it's really not only Europe for the ocean. And I was not in the D session on the aerosol, unfortunately, but I have the feeling that they're also thinking worldwide. So complexity is everywhere. Aerosols is not something that is only in Europe, I can tell. So I think complexity is needed for everybody.
Yeah, but didn't you recommend a task force on this? I mean, you said you do not recommend an extra activity now, and on your slide, in your recommendation slide, you recommended an extra activity on this. Or am I remembering wrongly?
Yeah, but I mean, I see that we did not, for the ocean, we did not recommend for FPS. We recommend for a task force in order to help somehow the domain.
Your Tuesday recommendation slide, not the one coming out of yesterday. That has your last slide.
Yes.
Had an effort on complexity in one of your bullet points, if I'm correct.
Yeah, one of the bullet points was if you want to investigate a new component that was never touched, so not the city, not the aerosol, something that is new, for example, sea ice or glacier, then we can dedicate it to FPS there. That will then feed the domain. The goal is to develop a community, a strategy, standardization, and then we feed back the domain. The problem is to feed back the domain at some point. And it's also why we do not ask for FPS for the CORDEX Ocean. We want to sit in the domain, at the domain table.
Yes, nice. You can sit in the domain. Okay. So I
really would like to encourage ESD people to come up and open the discussion, because we are all the time talking about the importance of integrating regional climate models and ESD, but now we have to discuss ESD, so we need ESD people to jump in. How can we integrate? What kind of coordinated activity is already planned? I know there is a protocol, but is there anything going on with this? Jose Manuel has gone. No. Maybe Maria Laura, you want to say something about ESD? You are, I don't know, is there anybody who wants? No, silence.
Andreas, please.
I'm not Andreas, but still. I'm not an ESD person, but for sure we need the statistics. We provided convection permitting simulations to impact modelers and they weren't happy at all. So we need bias correction, which is a close relative to ESD. So we need this community for sure.
But I'm sorry, but I hear since 15 years we need the connection to the community. And I had Erasmus here talking about it every other moment he got the microphone. So I think we really have to make a step forward here and go beyond. We have in EuroCordex, a long time ago, it has this distillation pillar. I don't know if it still exists. We have the entire RIFs ideas, which I guess, and if I understood Bruce correctly, goes along the distillation, at least in some areas. So nothing we need to discuss here. It's all fine. Do we need a plan? Do we need a task force? Do we need different people? Please.
At least I can talk about emulators maybe, which I believe that are one way to connect really RCM and ESD communities. And we could, but we could design some like common protocol on, like, I was thinking about that when we were talking about the core on Africa. Like it could be a typical case study where we join dynamical and statistical downscaling through emulators forces where making from it like a real case study to see the potential of these tools, because standard statistical downscaling has quite a lot of limitation on Africa because we don't have enough record of good quality observations. So I mean, in my head, it was always the kind of place where emulators have all their room.
So maybe we should discuss an extra activity, kind of a mandatory activity. I would also encourage the ESD to think about common storage to make the data available so that you can download as you can do it with the dynamical SEN.
Yes, thanks. So just to regarding the distillation theme, I think it came up frequently on this conference. It's not the same as ESD. I mean, it's to me, it's a bit wider. It concerns the GCMs coming in at that resolution. We have observational constraints and stuff. So there's surely something we have to better organize to merge and to digest what we have as information. That's distillation, I think. ESD is one thing. Now machine learning is coming in. And actually what we discussed yesterday, so Laura and myself, is to push that a bit with a workshop or with a task force related to the EuroCordex meeting next January, or even in a wider Cordex context. And there's surely potential and synergies that we should use here. But it's not only about relating ESD and RCMs, but it's bringing in the evidence that we have to make something useful. Yeah.
Yes, Daniela, may I just come in from Pune?
Please.
Daniela?
Yes, please go ahead.
Yes, I think what is being discussed is quite important for our region here in terms of Cordex South Asia. And the questions that you put in terms of, do you need a plan or a task force or a common protocol? I think while we were discussing here, the idea of also regarding the huge volumes of data and products that are coming up, that needs to have an integrated platform, a platform whereby it's not only about putting in the data or accessing the data, it's also about putting in some of the products and the knowledge that is there. So it's more integrated in terms of being useful for not only the climate modelers, but also using it by various sectors, like for instance, the sectors plus the hydromet agencies, issues of like, we also talked about, making it available for climate services, for instance, so that that is translated down to the various users. So I think looking at all this, this is like a process-based more or less. So that does need to be thought through in terms of how we want to do that better, because it's not only about data, it's about knowledge, information knowledge. So we need to go a little bit beyond just data and make sure that it is being translated in a way that it is useful for the various users, various sectors. So for that, I think a little bit more thinking needs to be put in place as to how we do that better.
Yeah, thank you very much. Bruce, please.
So picking up on the word distillation and the mention of RIFs, distillation is something in a bigger picture, a bigger issue around there. And I think it's not necessarily something that Cordex leads, but I think Cordex needs to be intimately engaged in conversations with the other communities about how do we address this multiplicity of messages depending on the data source that you choose. And Cordex is a key one around that because people often go to Cordex because it's higher resolution, perceived to be more robust. But I think this needs to be a community effort that goes beyond Cordex, and Cordex needs to be a strong player in that.
Absolutely. So I would like, we have one more Samuel, and then we turn to the next topic slowly. We plan to wrap up at 11:30.
Just to reinforce what Antoine was saying about emulators. So I think those tools are really, they have the potential for a few list of variables to produce a large amount of data for every continental area in the world within the Cordex framework. But for that, we need to design the simulation we perform for the training. So we need to couple the dynamical and statistical downscaling from the start, because the simulation that we perform, we have to think that they will be used for the training, and so they should be adapted to this. So, but this can reduce a lot the amount of simulation we have to perform over the different continental area that then will be expanded by the emulator. even if, I mean, I'm not saying emulators are ready to work. I mean, we have a lot of science to do on it before and publication and so on, but the potential is there.
So in addition to what just Bruce said, may I just come in again? Just to add on to what Bruce said, I think to expand it and also to see that, to synergize the work that CORDEX is doing with what RIFS is there to offer. For that, I think CORDEX South Asia is quite willing to be working with the RIFS and trying to see how we do that better. So I just wanted to emphasize that. Bruce, did you hear that?
Thank you, Mandira. So Maria Laura, please.
Yes, just a small comment. I agree. We were talking a lot about statistical downscaling in this conference. I think in this conference, the statistical downscaling was heard a lot more. So I'm very happy about that. Because we were working a lot since a long time ago, I think 10 years ago, Bruce and Bill sent me an email to invite me to participate in these activities, and well, I'm very happy now that we are. I'm hearing a lot about the statistical downscaling. So I was talking a lot about about this. We need to coordinate. We need to push this coordinated experiment. I talked with Anton. I talked also with Ramon. I didn't have the chance to talk with Jose about this, but well, for sure, we are connected. We need to push this immediately, I think. So, well, that's. Thank you, Maria Laura. Yes, it's needed because we need to integrate it. We have done it within the flagship pilot study in Southeast and South America, but this should be also coordinated and also has been done in Europe. But we should expand this to have this integrated evaluation of both tools over other continental regions, CORDEX. So if we don't have any further comments on this, yes, please. Online.
There's a comment from Christian Stiga, who says that for the CP simulations, there is an additional organizational question for each CODEX region. Should we go for more simulations on sub-region domains, e.g. France, Germany, with only one or two models, the ones working in the sub-region, or should we keep the large continental domains, but then probably with fewer runs because they are very demanding in terms of resources? And then Annele said, maybe the ESD community can also help in providing the much needed observational data set for the high resolution simulations where observational data sets are limited, e.g. Africa, or to the planned continental scale CPM simulations.
I don't think we are planning continental scale CP simulations because it's not feasible at the moment, I guess. So we are just discussing how we deal with coordinated activities to have at least a couple of simulations over different subcontinental areas, focus on phenomena. So this is the feeling in the room today. Yes, Chris. Yeah.
Just a thought on the data requirements in the modeling is within the CORDEX leadership and just because you mentioned task forces earlier, Daniela, could we think about establishing a task force for cloud computing or to explore cloud computing? Just based on a number of the discussion or comments that we've heard here, storage, running models, the compute capacity is a big question. So perhaps if we establish this kind of task force, it might be useful to look at that.
We will talk about this later during the SAT meeting.
We have one more comment, I guess, from online, and then we would like to discuss with you a little bit the future of the FPS.
And two more comments from Christian Stiga here. He said, On the commitment for simulations for all domains, for a national med service, at least for DWD, it is difficult to work on other regions than Europe. We have simply no mandate to do this. And he further said that on the GCM resolution, other activities than SIMI7 will go for global convection permitting simulations, e.g. destination arts.
Yeah, but that's part of the future, and that's part why we are pushing for benchmarking and knowledge. So I don't think that we will have continental scale convection permitting simulations ensembles soon. So, being honest, but it's good that we hear this and that certain groups are pushing for this. We heard the two different words on instruments. One was the FPS, the flagship pilot study, but we also talked today already about task forces. You might have been surprised, some of you, but during the course of the week, there were some suggestions that we organize ourselves in addition to the instruments which we currently have, also for specific issues in task forces, which can be short-term living beasts or longer-term living beasts, I don't know, but they have a specific, narrow, clear task, not an overall explain how the connection between monsoon and convection permitting modulation is. So a very specific task. And I think this is very successful in CMIP 7, I guess you said, Krisha, where they work with a lot of task force. Was CMIP 7? Can't remember in the setup. But maybe you can explain a little bit how the instrument is working in that community.
Yeah, because it's basically CMIP 7, I think 6 task teams, but basically they created to develop and to prepare CMIP 7 experiment. So it's not really task teams on processes or something like this, because one task team is responsible for developing new scenarios, other task teams for preparing infrastructure, for data requests. So it's really practical questions. Yeah, so because maybe we need to separate between such kind of technical task teams and task forces or whatever else that focusing a little bit more on processes or some coordination of activities for coupled ocean atmosphere regional modeling. Yeah.
Yeah, thank you. Yeah, we had, we will discuss this further and think about it a little bit. I think it's very clear that the FPS is a very, very successful instrument, and you all have worked very, very nicely, and a lot of progress which we saw has developed from FPS, and this will stay. So it will be continued. I know that a few of you were asking, will there be a call for FPS soon? And we are discussing this afternoon. Pretty sure there will be a call, maybe slightly adjusted to today's needs, but we will have to discuss it in the scientific advisory team. But for sure it will stay, I would say. It is always also a good community building instrument, so it can have different flavors and different ways forward, and it's also a good instrument to connect to other communities, as we heard from Urban, for example. So I think that is something which is very clear and where we like to go forward. So do you have anything to say related to the FPS kind of instrument or structure? Jason.
Hi, yeah, I agree that FPSs have been very successful instrument for CORDEX. To a large extent, I feel like one of the key roles they do is build communities around particular focused topics. For people who are thinking about new topics and potentially new FPSs,
it might be really worthwhile exercise to go to the leaders of the FPSs that are very mature or even finished now and collect some lessons learned, best practice, a little bit of guidance for people who might be looking to develop new FPSs so they don't have to go through the same hurdles these guys have already solved.
And Jason, we have already done that. We have collected all those inputs from FPS's PIs already. So, yeah.
It'd be great to put it together into some sort of guidance documents that people could use.
Yeah. So, Sam?
My push would be for keeping a large degree of freedom in what we can propose in FPS. So not constraining too much in your new call. So in order that the community can be very free to propose something that is completely out of the scope, like trying to travel at a speed faster than the light or whatever. That's one point. Then don't forget that some FPS would be probably geographically centered and the other ones will be multi-domain. And also something that I missed in the past year, that once the team was starting to build the FPS, very often a large part of the community was not aware. So, I mean, the people done that by like a small scale networking, but then we could also have a larger call for contribution. I don't know, using the large WCRP emailing list or the CORDEX emailing list, in order that any team interested by a given FPS has a chance to contribute.
Thank you, Sam. And I think before any other comments, I think that we should also try to look the way of integrating the knowledge gained through the FPSs into what the coordinated CORDEX activities are, because FPSs are successful, but we need to bring them into our scientific knowledge advance and providing these benchmarks to other activities like EVE, like other ongoing activities. So this is something that we should take into account for the near future. So any other comment on FPSs?
I think we can also open now if you have any other comment. I was just approached by someone I cannot see from here about CORDEX. There you are. Okay, up there. And then the last five minutes, I would like you to comment on this conference, and what you think about the conference, what we would plan the next conference in 4 years from now. Should it be a similar style, and so on and so forth. But maybe first let's go back to CMIP, please.
So CMIP 7 is also new, and for the first time ever, I mentioned this on Tuesday. There's a appetite to prioritize climate service relevant experiments. And you guys are one of the two main communities we're thinking of informing. So is there a CMIP, is there a CORDEX feedback in terms of what you need from a climate service relevant experiment track? How do you feel about CMIP 6 in terms of the availability of boundary data? Do you want us to recommend availability? Are there particular experiments you're more likely to use? And so this kind of decisions about what is in the fast track for CMIP 7, which is going to inform simulations in 4 years' time, 3 years' time, will need to be decided in the next 3 months or so. So individually, but also could there be a collective CORDEX response? Or
yeah, thank you very much for bringing this up again. We will have it also on our SAT meeting agenda, and we will try to get an organized answer to you. And like to be very close in touch, especially those modeling centers in CORDEX or modeling or activities which are also climate service activities, mine, for example, but also others. And so I think that we're very, very good. Thank you very much. Are there more topics we haven't touched yet? There's another Samuel. No, there's someone else. You wait. So where was? Okay, please.
Yeah, just a minor comment. I think in order to get the information exchange, information management, etc., going, that is necessary in order to, yeah, in fact, get all these things that we have been talking about really going, also in a transparent way, in a cross-domain way, and so forth. I think we should make use of our WCRP CORDEX GitHub infrastructure more. It's more like a small comment. It's a technical issue, but I think it would help tremendously in terms of information management. It can go like from name lists all the way up to domain specifications, which are already there, and so forth. I mean, I just wanted to make that point in the plenum, so it's not forgotten, because I think that would tremendously also help in perhaps bridging between domains, bridging between different communities, and so forth. Yeah. Because we see that in other parts, it helps tremendously in order to make things transparent and more efficient.
Thank you. Samuel, do you have a microphone? And Teresa.
Sam has talked a lot, so first me. For the next conference, it would be nice to have the posters available online like 2 weeks before or something like that. Many of us were not able, we didn't have the time to go and see the posters. And it would be nice to have that opportunity to see that kind of information, because it's very important, and highlight and see what is being done in all the domains. So that's an option.
My comment is that since the beginning of the morning, we speak a lot about modeling and organization, but there is something we miss here, is what are the scientific challenges that are in front of us as a community. So there is, I mean, at some point, we should list what are our key challenges that we are facing and we want to solve. So I noticed only 2 in my notes, but probably there are many more. I think there is a past trend representation and understanding. So are our simulation able to reproduce the past climate change for good reason and to help understanding why those trends are there? And this may be deriving even regional climate model selection. So if you are not able to reproduce the past trend, not sure you have something to say about the future. And the second point was something you mentioned yesterday, Daniela, is as a community, could we start to provide information about never seen phenomena, like either phenomena that was really never seen or phenomena known but not seen in a given season or in a given place. I think we are the community where we can really start to do so. I really agree with you on that. But then we need this list of key scientific topics that can be handled anywhere in any domain.
Yeah, thank you very much to bring this up again. I think this is important, and I would like to remind you that we have also this the papers, the CORDEX papers. I mean, the future, with our future challenges, but also the ESD paper, we're thinking about more, and we will from here onward with the input which we got here, and this morning was more on the coordinated activities. That's correct. But we will, of course, with you further develop our scientific way forward, and this will come up, and there will be possibilities for you to feed in beyond this conference. Sure, please.
I think for next conference would be nice to have short presentation from different domains about the status and progress and what they're planning, because when people probably other people than the people very involved, they don't know. So that would be useful. The other thing for me with the current cycle is that we still haven't finalized the data syntax and delivery and things like that. And I think it would be good to be a bit more sharp on these things. So we actually put things down and people can go on with work and data delivery.
Thank you. Erika?
Just going back to the new scientific question or the new topic we could include is some of us and the research is moving fast forward. They are involved in this new scientific current of the attribution of climate change. And many of these community are using our model, especially in Europe, like the CORDEX, to support this attribution study. So I wonder if within CORD and also elsewhere, because we also look at events elsewhere. Like for example, a flood in in Cape Town of 2 days ago. We just looked at it with Chris yesterday. So I was wondering if CORDEX wants to have a role within this community that the moment is quite coordinated. I mean, it's just driven by project and interest, but it's something that is promising also to extend to validate our simulation in the near future. I mean, can we use this methodology to say something?
Yeah, thank you very much. I think we are close to finish. So first of all, I would like to say that
another
Silvina
thing
has
before,
another point.
Yeah, no, but just another point, because we really need your feedbacks on the conference, because we have to plan, we have to see when and where, but we would really like to know what are your thoughts on the good nice things and the not so nice things during the conference. So Irene will send out a sort of template for you to fill in, and we would like you to invite you to fill in that template with your thoughts on this, because it's very important for the next step. Yeah.
Yeah, so I think we are coming to the closing part. I hope Pune is still with us. I hope so. You're somewhere in my back here. First of all, I would like to say that I think the conference was very successful. The idea with the 2 hubs, I think worked very nicely. Maybe we could have gotten a bit more in dialogue, but we tried. I think it was an experiment. We haven't talked much about sustainability, but this was part of our sustainability concept. So we will have a task force on the sustainability concept for CORDEX. Sure, we need one, because we cannot just do what we like. Regional climate modeling and what we are doing is often very energy intensive, but you all run on renewables, I guess. So I think this concept, I think, worked out very nicely. And now I see you here in the back. Good, very good. I would like to, before we close, to say a few words here about the entire setting. And I would also ask the IPO staff plus the local organizing staff to come into the room. I see you're close to the room there. First of all, I think the setting was having information on the scientific progress on a potential role in interaction with society, on interaction with impacts. Having these parallel these sessions, I think, was, to my opinion, very interesting concept. I must say I missed lots of interesting things because the parallel was too much in parallel, and we have to rethink about this a little bit. But I would like to thank you all for your activities. And with this, I'm starting here now. So I would like to first thank Irene and the IPO and the local organizing committee. And the same, I would like to thank the local organizing committee in Pune. So also to you goes a big clap here. So So without your I would say more than a year-long work in preparation, and with all the great work which was also made in Pune for organizing these two hubs, and you couldn't really feel a problem, could you? I mean, there was no problem in working with the two hubs. So I think besides that, the remote control is missing. So please check if you have the remote control somewhere. So I think this was really great. And again, a big applause to the organization, the local organization, the organization on the administrative and scientific side before the conference, during the time of the year, and on the conference. So a big thanks to all of you. I also like to thank the all session chairs and all actively engaged organizing little entities. I don't know how I should call them, and FPS leads and the early careers, the rapporteurs who were very active and very engaged, your willingness to jump in when we needed someone and everything, I think was all timely. We got all reports when we were needing the reports, and this was really great. So I would also like to thank those with a big yeah. And this is also true for Pune. We got overnight the wrap up of the sessions, which we did not attend when we were early in the morning sleeping. So everything is now collected and will be considered and will be used further for our development of the future of CORDEX. I also like to thank the SAT members, all of them. So I think you did a tremendous job in the run towards the conference, but also here. So SAT members who are in the room, please stand up, come up here to us. Not everyone is here anymore, but please, Melissa, Jason, Teresa, Gregory, maybe I missed someone. Please also come here. I'm done in a second. And I would like to also thank you and Sanjay and also the SAT members in Pune. Please stand up, so that we know that we can see you also. So thanks to the SAT members. Without all your good work and comments, this could not have happened. And I would also like to thank, of course, Silvina. And Silvina she is the continuous calm and always positive voice in the back, and without Silvina, this would also not be possible. So, and before I hand over for the last words to Filippo, I would like to thank all of you, all the speakers in the panel, on all your contributions were very helpful. We tried to have a kind of a presentation heavy day and dialogue days. And I think the lively discussions were really helpful, and I like to thank you for your engagement in CORDEX, and keep going.
Okay, so just well, first of all, of course, thanks to everyone. I wanted to really give a super huge applause to Pandora and to Susanne, both of them here. Both of them have to come here. And you cannot imagine how difficult it was, because we have a procedure, very strict procedure, but I'm not the only one to retire these days. Pandora, actually, today, I think, is your last official day as an ICTP staff, and she didn't need to do this to help for this conference. She volunteered to help for the conference. So this was a super duper thing. So we have And the T-shirt, I guess. So thanks, Pandora. Actually, Pandora has been with us for 23 years. Pretty much the same time as I was, more or less. So I really want to personally thank her for all that she has done for us, and wish her the best for the next stage of her life. And with this, thanks very much to everyone, and well, good luck for the next CORDEX conference. Okay, bye-bye.
Congratulations. Okay, then thank you to all of you also. Thank you very much to once again to all the local organizers of this conference, including our live streaming people who had been throughout keeping us live to ICTP. Thank you. Thank you all. Thank you all for coming. Have a nice trip back to your homes.
Danke.